Good morning, everybody. We are very happy to be here and to have you connected with us. So we are starting now with a great pleasure the Human Body Interaction International Symposium. I'm here with my colleague, partner and friend, Professor Michele Zannoni, which is Associate Professor at the University of Bologna, while myself I'm Roberto Montanari, and I'm professor at the Università Suor Orsola Benincasa of Naples and Bologna, and I'm R&D responsible of RELAB. So we are very happy to have here today for a very interesting and impressive day with a lot of projects and initiatives. But let me take just a few words about the institutions that have supported us in creating such a big experience like the one that today. So thank you very much for supporting us, the Dipartimento di Architettura dell'Università di Bologna, Department of Architecture of the University of Bologna, the Advanced Design Unit of the University of Bologna, l'Università degli Studi Suor Orsola Benincasa, the University of Suor Orsola Benincasa from Naples, and the CRIC, C-R-I-C, Centro di Ricerca per l'Interazione con le Industrie Culturali e Creative, a research center on the interaction with the cultural and creative industries. So once again, thank you very much for being with us, and I leave the word to my colleague Michele Zannoni.
Okay, I spend a few words, some minutes to speak about why we are here in the theater. And all the events are on the digital platform. We are online, but all the advanced design unit is here in the theater, because we want to try to understand the relation from the physical, the relation between the people in the absence of the body. We decide to create our tools for understand in the space how the people create a relation. We create a specific platform, online platform, to create the connection with the people, but also in the theater, we create a visual installation of the people that in this moment are in the online platform. Also in the platform online, you can find all the results of our research. You can see the case studies that we collected during the research. You can see the tag, anything, any kind of information that we try to investigate to understand the complexity of the relation between the body and the interaction with the machine. Okay, in this part of the research, we try to understand how which is the themes for carry on a research, carry on a network in the create a relation between the people, the academy, the company, to grow out a network on the relation of bodies and the design process. And now I call in the stage, but in the virtual stage, the head of the architecture department of the University of Bologna, Professor Fabrizio Pollonio.
Hello.
Okay.
Do you hear me?
Yes.
Yeah, okay. Good morning, good afternoon, or good evening, everyone, depending on where you are. Thank you so much for being here today, someone in presence, I hope, and most of you remotely connected. It's a great honor for me at the beginning of my office as head of the Department of Architecture to be here today to bring you the welcome greetings from our department. And above all, I'm honored to open the Human Body Interaction International Symposium. This is a project on which the proponents that I really thank have been working for about a year now. Unfortunately, due to the COVID pandemic, they had to postpone it and for so long. but they finally got over it, proposing this innovative, creative, and challenging way of using a symposium that strives to merge an online event with a data physicalization process. I'm looking forward to see too, even though remotely, how all guests and participants will be attending online the symposium, while their presence will be reported on the stage and in the audience. I guess it will be really a complex experience of storytelling and comparison in blended mode, but we hope, I'm sure that you will enjoy this experience. This is the fifth event of the Future Design Symposium linked to studies on the anticipation, and it aims at researching new scenarios in which the body will increasingly become the focus for the purpose and the target of designers. The symposium was born within the Advanced Design Unit of our department. Although the research group was established within our department a few years ago, it immediately demonstrated to be very attentive to the phenomena of transformation of the design disciplines. The Advanced Design Unit research group, therefore, has already proved to be a very important reality on research topics for the innovation of the territories as well as of our industries. The project has been realized thanks to the funds of the Department of Excellence, which have been helping us to open new directions of investigation that we hope will become resources for our territory and in the long term. The inspiration that led this research has found new life in the work of Flaviano Celaschi, who last year published the book Human Body Design, and in Andreas Sicklinger studies on ergonomics. Michele Zanoni and Roberto Montanari, that you have just known, contextualized and searched together with a team of fellow researchers the project, revealing a framework of innovation processes in the design field, on which it will be interesting to focus your and our attention in the following years. We firmly believe that the territories and industries of our region need to activate innovation processes related to the development of interfaces, medical or sport wearable devices, but also new solutions for the interaction between body, objects, and space. Before concluding this short message, let me know to make my most sincere thanks to the group of proponents, Flaviano Celaschi, Elena Formia, Andrea Sicklinger, Roberto Montanari, and Michele Zanoni for their commitment and their energies, to the scientific committee who believed in this challenge, and to all our and their collaborators of the organizing committee, Giorgio Dall'Osso, Marco Pezzi, Luca Barbieri, Alberto Calleo, and Arianna Fantesini, Lucrezia Rivecchio, and Ludovica Rosato. Thank you again for your kind attention, and I wish you to enjoy the rest of the event. Thank you so much, and bye-bye.
Okay, so once again, we are here. We are very thankful, Professor Apollonia, for the opening speech. And now we are here with a keynote speech. So I'm very glad and happy, together with Michele, to leave the floor to Professor Andreas Sicklinger. And the speech is titled From Ergonomic Studies to the Human Body Interaction Design. So Andreas, the floor is yours.
Thank you very much. I hope you can hear me. I also need to express my thanks for this invitation to give this keynote speech. This very interesting symposium, which has been realized by Professor Michele Zanoni and Professor Roberto Montanari, together with all the staff, I think is really a milestone, also in the understanding what kind of responsibility design need to have in the present, but also in the future, perhaps especially in the future. So I would like to start to share my presentation with you. So as Professor Montanari already said, the title is From Ergonomic Studies to Human Body Interaction Design. When I got the proposal of this title, still I was very much interested in a kind of interpretation of the whole studies, which perhaps is not so much related to realistic projects, which you will most probably see in the very coming keynote speeches, but a little bit about the reflection on what science fiction is proposing us for a possible future. So I, let's say, interpreted this title into the dark side of the story, but please don't think that I'm, let's say, a dark person. Definitely not. At the same time, I think we need to think and reflect about possible scenarios in the future in order to be able also to understand our present. I start here with it's a commercial by Serif Industries, and I will comment on it later.
It's changed my life. It's enabled me to do my craft, to do my one passion in life.
Taking pictures, easy as blinking my eye. Now when I take chances, when I take risks, the whole world gets to see what I see. I want it to be better. I want to be best of the best, part of the elite.
Football's always been a big part of my life. And after what happened, I didn't think I was going to get to play ball with my son. And to be able to come out here and play ball with him, it's like a new life.
It's super cool. Now when we play football, he can like throw way further.
Run faster, jump higher. If I want to be the best, then that's what I got to do.
I actually can feel things. I pick up the football, I can feel the pigskin on my fingers.
I play the piano a million times more than I ever played it. It's easier, I'm enjoying it more, and that's why everybody knows me, is for my serif augmentations.
Thanks to Serif's augmentation, I see the world in a whole new light. I see it like I've never seen it before.
It just feels like a real arm, but better. You feel like a pro athlete with it on. It's been really like a revelation.
It truly, truly has changed my life.
Serif Industries. To learn more, visit serifindustries.com.
I got very much attracted some years ago from this commercial, and in the very beginning, of course, as many perhaps were thinking, it is something real. Of course, it is fake. It is, let's say, based on a video game, Deus Ex, but it is so much convincing, the idea, because human beings themselves like to be competitive, to be better, to be the first ones, to be have features perhaps that others do not have. And this way, like a commercial telling you there's an industry who is able to substitute a piece of arm, your eyes, whatsoever, in order that you get the best out of technology, and being better than regular human being is absolutely something convincing from a marketing point of view, and which is definitely scary, I believe, especially when it's well done, and you would start to believe that that's true, then the lie becomes really very dangerous. From where the whole thing starts, this dream and fear of this in the same time to improve through technical innovation, the ability of the human bodies actually goes back even to the beginning of the Industrial Revolution. Think only about the novel of Mary Shelley, Frankenstein, where a doctor is experimenting, and the victim, or the result, the object, the living object, or artificial human being, which is the result, of course, in the end, gets against his creator. Can't most probably not be different than this. So this is, let's say, a little bit, and as it is written already in 1818, it's a very start from this kind of looking at medicine and its innovation and capacities of, let's say, getting into the body of the human being, are really impressive. It doesn't take very much time. In the beginning of last century, there is the artistic trend of futurism, and a very interesting quote is the one of the Manifesto del Futurismo, which says, "With us begins the reign of people separated from their roots, that of the decayed man who melts with iron and feeds on electricity. Let us prepare for the imminent and inevitable merging of man with the engine." It's of course a period where really you see steam, motors, engines, movement, speed is characterizing all the innovation, the factories, life. Life is getting frenetic. It's getting incredible. Like somebody in the book titles said, it's the age of nervosism. People get sick even from this new way of being speedy, fast, which of course then brings also pollution and so on. And I show here a little sequence I also liked very much of Steam Boy. It's an anime from 2004 referring to the World Exhibition London 1862, where a man who got an accident substitutes parts of his body with mechanical parts in order also to be able to integrate himself with a machine, which I think is definitely a clear visual interpretation of what Filippo Marinetti was meaning. That the body is a kind of machine, is a structure which is made by components, actually is not something very new. It's very interesting to look at the drawings of Leonardo da Vinci, who is one of the very few ones at the beginning to be able to go to cadavers of human beings and make researches on them. As you know, the Catholic Church was completely prohibiting any kind of interaction with dead bodies, especially for medical researches and so on. However, evidently for his incredible talents and other connections, he was allowed to do this. For example, Michelangelo did it in a hidden way. He also did this kind of researches, otherwise his sculptures most probably would not be like how they are, but it was, let's say, not allowed. Leonardo got this permission, and the interesting thing is he not just made a kind of catalog of the human body. If you see his drawings, anatomic drawings, you will find that they are really like modern atlas of anatomy, but also he interprets. He tries to transform the drawing, the human body into a mechanical system. For example, here the neck, which he compares with the of a ship, where the ropes can then turn the head around like the ship is doing with the tree. So it's a very interesting way of looking at the human body, which he continues, for example, in looking at the heart as an oven. So he's imagining mechanically how it would work, but also all the ankles and so on becomes for him turnable joints, and in a very, very interesting way, up to the fact that he was also proposing processes of how to substitute missing or damaged parts of the body. So, of course, the other side is that he was then also designing robots and mechanical structures, which we all know, which somehow imitate nature. This leads us, if you go back 19th century, 20th century, to this kind of feeling that now science can do more and goes over nature and biology. And perhaps the one which is most interesting and clear for us is the hypothesis of the Übermensch of Friedrich Nietzsche, which is a kind of creature which is able to perform better through an above average health. That's the point. So according to Nietzsche, the future person will first and foremost need one thing, great health, which, let's say, helps him to perform more and more. So it needs something to be constantly acquired and has to be acquired, because it would go always away and he needs to continuously improve it, which in the consequence of this statement at the end is you need healthier people, dangerously healthy people, or rather Superman, which is one of the translations of the Übermensch, which is then whose reward is to have a still unknown country in front of you. So this Übermensch, this kind of Superman, which is the result of incredibly good health and most probably also in the later stage improved by medicine, will get into borders and other, let's say, fields we still do not know. This comes from the book Thus Spoke Zarathustra, which me myself reminds them very much to the last scene of Blade Runner, when the android says, "I have seen things you people would not believe."
I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watched sea beams.
I stop here, no need to go further. You most probably also know this scene. Interestingly, however, to refer to it is that he claims in the end the right to life because you know, he will die after this scene. Why? Why he is claiming for life? Because he's a better or a more performing being than the human being himself, and he believes that this gives him the right to live. Let's say from an ethical point of view, we don't judge this now, but it is really interesting that the idea of here the Blade Runner is that we create organisms, human-like, who are able to enter in areas and do jobs and activities which regular human beings are not able to do. So they are much more performing. That this actually happened also in reality is the example of miner Stakhanov, which in especially in Italian I hear it often Stakhanovista. So this person who is highly performing, which then becomes actually in the very end a different kind of meaning, a more meaning about too much working, a workaholic who is doing too much. But the interesting fact about is that he mined 102 tons of coal in one shift. That is 13, 14 times more than the regular one of 7 tons. Of course, this made him famous. He already was a worker who always had more results, better results than the others. I found out that he could reach this through a special technique he developed to, let's say, mine all this coal. And of course, for the Russian socialism at that time, he was the ideal person. But he ended up badly. Worsening alcohol problem and ensuing incidents eventually led to an ultimatum to leave Moscow within 24 hours. So from let's say, a throne of being the best among the workers, he went down to earth, being most probably one of the last ones. So this kind of responsibility, the social dimension, is also visible when we become superheroes, when we would be able to do special things. Then we have also a higher responsibility, of course, social responsibility, which in this kind of novels of Marvel, Superman, Spider-Man, Batman, which are like, of course, we are reminded on, never really come to this question, although, of course, superheroes are the ones who would save the world. And the famous sentence of Uncle Ben to Peter Parker with Spider-Man says, with great power comes great responsibilities. Of course, a bit of Americanism in this case, but it would be absolutely true. And perhaps you know that an athlete who has both legs artificial is not allowed to go with his these legs in the streets because he's too high performant. He would be too fast. With the advance of medicine, of course, what Mary Shelley already was portraying, these transplantations, repairs, improvements, and of human organs always improved more and more and more. But what I believe looks more like a future Übermensch instead of a Spider-Man or a Batman, perhaps could be a person like Molly Millions from the famous novel Neuromancer of William Gibson. She's a so-called cyborg, so a kind of mix between human body as a basic with some augmented features. Metabolism, sensory input, reflexes are artificially heightened. And then, of course, she has some defense tools like very sharp fingernails and vision-enhancing mirrored lenses. I'm not going deeper to this, but I could imagine that this kind of image of what people would like, perhaps sometimes, especially the ones who are a little bit more aggressive or soldier or so on, would like to have as features. Others, as we saw in the commercial of Seraph, is perhaps more be able to play piano in an amazing, beautiful way, better than any kind of professional. So that's the point now. What does mean cyborg? When and why does a man become a cyborg? There are some reasons. Cyborgization is to save a life. He got damaged in an accident, in whatsoever, and he get integrated with technology. He can also restore skills and body parts, always when perhaps has been a problem by disease and so on. But also, and this is again the proposal of Seraph, is to improve skills. So even a sane person could decide to substitute an eye because he wants to see better, even in the night. Here this film of Alita recently shows a little bit how a world of cyborgs could look like in future when medicine is really able to interact with human body without further problems. But if you think about applied ergonomics, human factors is already interested in these 3 points, of course. We want to save life by doing a better work condition. Rehabilitation and restoring skills of body parts is part, of course, also of medicine, at the same time of human factors. And we would like to improve by giving better environment and tools and so on, that the person can also be better. Plus, the other question is, would wearing eyeglasses make us cyborgs? So actually, this is the oldest prosthesis actually we have, which is the eyeglasses. And if you would like, we could answer with yes, but we can also answer with no. The term cyborg is very wide, and it's not really particularly defined. So actually, wearing eyeglasses could make us already cyborgs. The negative side of the whole thing is, we said about saving life and so on. But of course, introducing a lot of technology in the body makes also possibilities of data collection, of spying, of manipulating and so on. But also what comes out in the book of Paul Virilio, The Eroberung des Körpers, the conquer of the human body, is that the human evolution is weakened because medicine and technology is now taking part what evolution somehow would have taken away, and it's in such massive form that evolutionists, scientists think that human evolution is changing dramatically. Not only by this, also technosphere itself is changing the human body. I mean, we all suffer from sitting too much in front of the computer, staring into the monitor, and giving this speech, for example, okay? This transforms us mentally, especially also physically, no? Most probably I will end up like the man in the end of the evolution, sitting in a computer, like perhaps almost the same position like the monkey in the beginning, okay? At the same time, some more provocations, and then I will stop. Designing objects, spaces, and tools and experience, we are in fact designing the human being itself. This is a a sentence of ontological design. So we design things which influences us, but actually we are also design human beings in the meanwhile. If you see here, Graham, which is a crash test man, was created as a part of the new Australian road safety campaign by the Transport Accident Commission. Perhaps you have seen it. It is a sculpture in this term, but evidently, for example, the neck is one of the very delicate parts of the human body, so it has been literally eliminated or strengthened a lot. Okay, so a human being who would be perfectly adapted to his environment, in this case a traffic environment, would change form. And unluckily, I think we do already change form, perhaps by other means. Okay, a further evolution of the whole thing could be when our body sensations and action are transferred into another body, especially like here where the soldier has lost his ability to perform because he's in a wheelchair. He gets a new body, the physical avatar.
Thank you.
Thank you very much, Andreas.
Okay.
Presentation. I mean, you identify the roads that we have to, let's say, deploy today. So thank you again. And
you're welcome.
Let's move to the next phase. And let's say it's hard to introduce ourselves. So I'm introducing ourselves now. And it's time for the research report, which intend to outline what is, let's say, the preamble of the today symposium. So it will be done by myself and by Michele. So let's, sorry. Okay, just start to introduce. So from my side, let's say why we are here and sorry. Okay. So let's say why we are here, why we are here, and where we started from. So which is the preamble of the work that we are now presenting to you, a long work that we have done in this month, in this year, I would say. What motivated us to organize this symposium? When we started to discuss on that, it was, let's say, almost before the pandemic period. So the project started in 2020, as I said, just before that everything in the pandemic year happened. And it was under the intuition and the suggestion come from Professor Flaviano Celaschi, which introduced in his research activities a discussion which was intending to place the body in the center of the design process, which is not a trivial question. It's a very relevant question and relevant research path, as by the way, Andreas has started to introduce. The themes, of course, as you know, behind to the user-centered design, debate and approach. But as the UCD becomes a kind of an archetype of our design activities, of the activities which intended to, let's say, design next to the user technologies, the topic of the body, it happens to be sometimes, let's say, marginal or not in the center of the debate. Thanks to a recent book that Flaviano Celaschi has wrote, and is titled Human Body Design in the Transformative Economy, we have had a chance to see how actually the role of the body is relevant in the transformation of many products, of many services, and of course of many technologies, and how this element is going to become a center for the individual and the center for the designer. So that's the rationale behind our approach, and that's the intention that we have in identify within this symposium the role of the body in the interaction technologies.
The result is a project that led us to build a network of researchers, designers, and companies. The final aim is to build an observatory for activating a research process that investigates which implication of this newfound centrality of the body bring to the physical and virtual interaction process. In addition, a long-term objective will be to be a contribute with a new design-driven process to arise a collaboration from our territories with industries and universities. Before continuing, I give you some information about this growing network. After an initial request to take part to the project, we received a response from 44 people, both from academia, from profession, and from 7 different countries. We propose more or less 60 different case studies to analysis. A further work by our ADU research team has integrated this report to arrive to collection our database about 300 projects and 400 people in the 200 companies involved in this case study. From an initial analysis of the result, some considerations emerge. We started from 3 macro areas: homo faber, salubar, and cogitans, that open a research on the themes of a tool for men, for health, for prediction process. A vision emerges and describes many projects ready for spread in the market. On the slide, you can see this case study on the placed on the left of the screen along the axis that divide the well-being area and the homo faber area. On the right, you can see the case study linked to the use of the data, but the integration between data and physical things is growing in many projects, but it's a preliminary stage of evolution, and often, and in many cases, are the prototype of possible products. In the word graph, we can see the evidence that the axis on the left, there is a complexity that shows specific areas of innovation of a product already in the market. Instead, in the right area, there is many experiments in progress that presage a growth of new product and service.
So, having said that, I mean, we get from the first results, at least from the analysis of the senses that are involved in this, let's say, technologies investigation, interaction technologies investigation. So these cases that we have studied and the cases that we are going to present today have display a wide range of different solutions in the interaction, but of course has take care of different senses among the others. And so the first very, let's say, relevant results, which has to be highlighted quite significantly, is that, of course, the greater importance that we have in the sense around the description and the promotion of the body is the visual channel. So the visual channel in our analysis is one of the most utilized and promoted senses, but not just the visual, not just alone, but together with others, which make more concrete and, let's say, more physical, even in a digital environment, the perception and the experience of the body. So what we are seeing today in this research as, of course, as in the major role of the visual, a big relation, a big role of what is the most important senses among the others that we have. But from the other, we have some, let's say, revelation about the relationship between this sense and the other. For instance, we have seen, and you are going to see very important role played by the tactile and even more the active tactile, so the haptic experience. Haptic is a very crucial research area in the domain of the interaction because it makes the feeling of touching something, even you don't have something in front of you or together with you, or to perceive to be, you know, part of the, let's say, sensomotorial experience. So haptic is one of the senses that have been explored and promoted in most of our, or in many of our projects and in some of the ones presented today. And they are very relevant, for instance, when they play a role in the multitasking activities, as we have seen, together with another sense, which is not so much, let's say, investigated in the presented research today, but it's, you know, in a way relevant, which is the vocal and the acoustic. So we have haptic, we have vocal and acoustic, but we have also a kind of promising missing, let's say. For instance, the olfactory sense, which is, by the way, very important in the world, you know, during and after the pandemic. It seems to be something that the research are not investigating so much. And this is a kind of challenge for the future, combining this element with the other, because the missing of the olfactory and the improvement via interactive technology of the olfactory could make, let's say, people more aware about what happened, especially if something happened in their experience because of the COVID. And by the way, this has been recalled in many quotations in the human factors domain even recently.
To understand our activated anticipation process that help us to understand the complexity emerged after this phase of analysis, we have tried to highlight 7 study themes. The first is related to the relationship between the machine and the body, and how the artificial intelligence is used to improve the process of interaction of digital system with the humans. The second is related to the same concept, but in the complex sphere of the emotional recognition. The third and the fourth themes are linked to interaction with the physical and virtual artifact. The new tools and material can open up a new comprehensive interaction between the physical artifact and the digital dimension. The fifth theme is related to the absence of the body in social and learning relation. The COVID-19 give to this field of research an exponential growth in the direction of virtualization. The 2 last fields of research are mainly linked to well-being area and are related to the process of behavior change triggered by assisted technology intersect with the prosthetic element and wearable device. The last theme is focused on the sensory transduction, where there is a lack on the one sense. This is shifted via technology on the other ones. This is not a new design direction, but now is moving from the prototype level to the product dimension. In summary, these 7 fields of research tell about a complex scenario where the experiment that were prototypes at the beginning of the century now are becoming concrete B2B and B2C product. The first theme we highlight in this symposium show 2 scenarios of the human-machine relationship are emerging in the interaction project. From a model in which the human control the machine through the thin lines of the action and the reaction that constitute a traditional idea of interface, we are moving on an inverse model in which the machine learns from the human. The setup of neural networks capable to interpreting human movement increasingly in precise manner is gradually becoming a stable reality that can be implemented in the design process. Low-cost technology can give rise to a complex system of a relationship between the sensor and the human. Google's experiments with the TensorFlow Lite open source library focus on the low computer power hardware to track the human behaviors, show a specific direction in the integrate the AI in everyday things. A mature scenario is opened, in which the designer and the developer will teach to the machine to interpret the human gesture and can transform this learning process into a product really for the market.
So we have the role played by the artificial intelligence and you know what Michele said in the interaction, but we have another key role that emerged by our studies, and we have today a use case on that. It is emotion. So emotion, of course, it's a kind of area which has been investigated by technological development, by the analysis of the human behavior since a long time. But recently, technologies aimed at tracking the emotion has been grown, let's say, if not exponentially, at least geometrically. So that means that we are now facing a new experience in the use of these technologies. Many years ago was published a book, which is famous also for the label that introduced, that was titled, as you know, Affective Computing. And the idea was to have a kind of relationship between the computing and the technologies and the emotional tracking. Of course, the emotion are important because can help us. I mean, the tracking and the understanding of the emotion are useful and important because helping us to understand something more about the user status. Most of the traditional, let's call this traditional, but let's say most of the traditional research in understanding the user's, let's say, status and role are based on the detection of the cognitive status, like workload, attentional distribution, and whatever. But we have seen, since a long time that the emotion play a big role in combining with element like, workload or, attention distribution or whatever. So this kind of combination are very relevant, and it's important for, let's say, make the interaction technologies not only even more aware in respect to the user status, but also able to adapt themselves in the combination of these elements in making the understanding of the humans even and the body, of course, even more relevant. And by the way, we have today a specific project dedicated to this with the Italian spin-off SME, which is called Emoji.
Another theme is the new capacitive material. The last 20 years of interface development has been characterized by the continuing research to achieve a precise construction of the screen of our devices, more and more defined and accurate in the tracing of the touch on their surface. The rigid and the planar configuration is a limit. Other technology has tried to break this issue with the introduction of flexible screen in the market. But, however, the morphological limit of the form remain the point of crisis of this project, and also having the design integrate part of the screen on the no-screen surface with a capacitive sensor, but the digital shift between the real touch experience and this mediated interaction is very partial and limited. Recent projects, including the case study presented in the Symposium by company TG0, show us a new frontier of tactile interaction, which will lead us to a way to develop a new interactive system with that will connect the human and the machine through a deep control of the link between the body and the artifact.
And together with the new surface, of course, we have another point which is very relevant for today and for discussion about the body, which is the touch. The touch in the interface designer, let's say, experience, typically play a kind of tactical role. So when we understanding or we try to understand and guide something with the tactile experience, with the touch, we don't have as a design the same, let's say, semantic ground that we have with the visual channel. So tactile information, feedback given by the vibration or whatever seems to not give the same detail of the information given, by auditory or even more by visual. But from the other side, tactile has a key role, as I said, a tactical role, because they would help us to create effective multimodal interactions. I mean, interaction in which visual, acoustic, and other are combined by this sense, which help us to make things even more understandable and even more aware, and people, of course, even more aware, especially in multitasking condition, where we have to make more things than just interacting with technologies, and we can use the tactile experience as a key role. So their role is the role of the feedback, but also the role of guiding the experience. And the relationship between the feedback and the guiding experience is offered by the so-called haptic let's say, interaction modality, which is a kind of active tactile. The challenge is make haptic channel, so active tactile channel, even more, let's say, active and reconfigurable. That means able to help us to understand visual, to understand acoustic, to move in the environment, perceiving digitally the sense of the touch, the sense of the physical, let's say, interaction. And we have on that two key projects. And we are very glad to have them here today as the others. One is Ultraleap, and the other one is Tesla Suite. Ultraleap is working with the haptic technologies, with the contactless technology, which give us the perception of the touch in the space. Why Tesla Suite has designed and implemented the suite which has, let's say, equipped with the tactile and sensomotor responses, which give, and they are, of course, programmable and, let's say, actionable, that give us an even more physical experience of an immersive scenario. So both are promoting an even more concrete, even in the digital world, a more concrete experience in the immersive visual, let's say, virtual interaction.
If the visualization we are looking for to materialize a feedback to sustain the illusion of interaction, in the real world, the COVID-19 pandemic confronted us with a sense of the body as a shape of a new normality. The shifting of the interactive experience into a video framework, moving from the 3-dimension to 2-dimension of the screen, that for many of us seemed to be acceptable during this last year. However, a critical reflection on the limitation of the perceptive process of the totality of the body emerges. The most invisible part of the flow of the communication, in which a level of empathic emotion messages is often erased by the digital tool that we use to connect each other. Most invisible part of the flow of the communication are lacking, and the result is a problem with the fundamental part of the body language that reduce the physical component associated to the voice, to the sound of our voice. The absence of the body become limited in the transfer of emotion among the human in the relationship. Also, if we think about the arts field, the thing is more tragic. We cannot feel art in digital mediation. It's a very big problem. Try to imagine difference between a real and virtual museum visit or a streaming of the artist concert and the difference between the artist performance in live situation. We need to experiment. It's necessary to experiment in this field. The new form of restitution of the motion process, we decided to invite to this symposium the Arte Balletto Foundation with very recent project that investigate how to don't lose people emotion while looking at the dance choreography with a fully virtual environment. In front, a complete dematerialization of the dance physical movement.
So most of the technologies are aimed at promoting new experience or, promoting changing in behavior. And the behavior is a key point of our research and today's symposium. Behavior is something that we sometimes want to keep and sometimes want to change. But at least it's known from the human studies that the changing of behavior is a complex and sometimes, let's say, not effective task. Unless, as some researchers said, you don't find a kind of pathways, a facilitator, which help you to change your behavior, moving within a kind of channels from one type of behavior that you want to lose and another one which is expected to be more, let's say, convenient or more effective or more healthy. So in the world in which we are expecting to promote the quality of our behavior, the assistive technology would help us in supporting this kind of change. Interfaces and many media could promote this virtual behavioral change. Even not all of them are, using only one channel or, the typical approach, but they are combining elements as you are going to see today. And even more, as you will see how this kind of change will be promoted by new channels, by new facilitators that would help using a combination between physical and perceptive solicitation, suggestion, promotion, this kind of transformation.
Technology helps us to understand and we can involve in transformative process and now a mature factor in the replacement of a missing or deficient part of the bodies. As addressed several times, the theme of the prosthetic has acquired maturity, increasingly faithful rendering of the human body and the element of the nature. Functionality, fruition, and replacement are giving way a path centered on the process of the sensory transduction, in which the lack of one sense is transferred to another, but the use of a technology that commutate a signal in different representation of the sense. From Cyborg and Harbison's first experiment at the beginning of the centuries, which tried to compensate the lack of a part of his chromatic spectrum of the vision, to the recent research of the neosensory that we present today at the symposium. This scenario shows a potentially that leads us to imagine a design mutation of a perceptive possibility toward an increasingly hybrid sensorial communication.
So we have seen what we have done so far. You are going to see, or at least what we have investigated so far, we are going to see the great experience that our colleagues will show you in, let's say, digital real condition very, very soon. But what happened in the future? What we have done together has been to create a kind of permanent observatory on the role of the human-body interaction, a kind of, let's say, community of practitioner, researcher, projects, initiative, which put together, in a great completeness and in a kind of continuous updating the debate on this topic. So the Advanced Design Unit, which is, of course, the scientific mind behind this organization, is taking the role to be the promoter and the maintainer of this permanent observatory, of this research service, let's say, that intends once again to create a community of people, but also the occasion, let me say, to understand, you know, the evolution of the human-body interaction. So we are open to promote future experience, to make next action during the autumn and during the 2021, and try to create this community of people even greater and even more active. So thanks to be here, and the role to complete to Michele.
Okay, we try to make a conclusion. We are at the beginning of the process to understand the new relationship between the design and body, which has been approached according to the logic of the product of the market, but which is now changes toward the dimension of the design for well-being of the individual person or a people community. This relation between the individual and the people community. The 7 design direction that we have highlighted, discovering only a few parts between the 3 macro areas, Homo faber, Salbe, and cogitans, which have set up to investigate. The evidence of the case analyzed show us that it is now necessary open a structured multidisciplinary debate on these themes, which until now may only be analyzed about the emerging technology and the potential of the construction of the artifact and service. But now they could open a new age of transformative artifact for women and men and their bodies. Thank you to everyone that participated to this start phase of the project. Now, I call in the stage Marco Pezzi that present the first speaker. Marco Pezzi is a research fellow of Advanced Design Unit of University of Bologna that coordinate this project. And it's thanks for his work that we are here to talk about this. Thank you, Marco.
Thank you, Michele. Good morning, everyone. It's a real honor for me to introduce you to the first talk of the day. His name is Dmitry Mikhalchuk, co-founder and chief revenue officer at Tesla Suite, who will present his talk, Connecting Human Body and Machine. Enjoy the video.
Hi, my name is Dmitry Mikhalchuk, and I'm a co-founder and a chief revenue officer at the Tesla Suite project. Today we'll be speaking about human-machine interfaces and a few products that we've introduced in order to make our life easier. In a fast-paced world, and nowadays, people are looking for products and services that increase comfort, perform smoothly, and require ever more intuitive, natural interfaces. Technology is also increasingly in demand as a tool for expanding or even improving our own abilities and senses. More sophistication is needed in human-machine communication. We don't want to be restricted by having to carry complex devices, larger screens, and literally operate the 3-dimensional environment using 2-dimensional tools and interfaces. We need to reduce the gap between the human mental model and the way the computer, machine, or robot can accomplish a given task. Productivity growth in various industries with improved accuracy, safety, and speed of problem solving are also an important aspect. A never-ending need to improve the quality of life and well-being for people with disadvantages is a very strong driver for progress too. We are currently moving from the age of hands and touch, in which we operated buttons and knobs, to an age of mind and body, in which we use our body as a user interface. Human-machine interfaces are shifting to being gateways to ever more natural forms of communication between humans and machines. Hence, we find ourselves in the journey further towards a full immersion, a world in which our reality is overlaid, mixed, and even extended with the digital sphere. For businesses, the path towards such a world is characterized by a myriad of opportunities. Amongst many others, closer, more engaging, more personal, and much more emotional customer interactions, better ways of visualizing and analyzing the information. However, we would not exist if it wasn't for challenges. A new mindset is required in order to shift from familiar, even less convenient interfaces to a new one. We know that despite the AI being widely used nowadays, and we're being promised that one day it will be able to outperform humans in every aspect, well, almost. A human control is still required during the learning process of the AI. We expect intelligent environments to be able to think, behave in ways that support humans. By providing personalized, adaptive, responsive and proactive services in a variety of settings, such as our own personal living space, work, public places, and on the move. Humans are emotional and empathetic beings, expressing emotions not only in human-to-human communication, but also human-machine interactions. And as a result, an important challenge with regard to optimizing human technology, symbiosis, refers to how ICT captures and correlates emotional expressions, as well as how technology can express emotions and exhibit empathy in its behavior. The issue of symbiosis with humans with smart ecosystems is complex and multifaceted, extending beyond technical boundaries to a multidisciplinary approach, with the aim to also address ethical, societal, and philosophical compelling issues. As we can see from a couple of examples here, interfaces may introduce not only just a level of complexity for its acceptance and adoption, but also may carry a hefty price tag, time-consuming learning curve, and setup cost. Usability and ergonomics challenges as well. Wouldn't it be nice to have a simple, easy-to-use, plug-and-play interface that is also familiar to majority of potential users, which is also future-proof? Well, I believe we have an answer to this. Tesla Glove is an exoskeletal glove that we've introduced last year, which is capable of force feedback, positional and finger tracking, collecting biometrical data and about the user, and most importantly, it delivers physical interface capabilities inside a simulated environment. Tesla Suit is another good example of a two-way communication interface between the human body and a digital environment. It is designed in the form of a suit, yet it contains a number of technologies. It has a number of biometrical sensors, including EMG, PPG, EDA, bioimpedance, body temperature, EMS, TENS, and so on. With the EMS in TENS, it also doubles as a electro-haptic system, which outputs sensations sensations of touch, impact, from light to heavy, and so on. Motion capture system provides information on posture and position of a tracking human body. All these systems are capable of tracking the well-being of a user. Feed the AI with the data for adaptive machine response, measure body interactive performance, provide biofeedback, and is still wearable and soon to be a medical device. We leverage haptics to provide physical interface within the simulated world. Some of the real-world applications include various industries. A good example is Volvo, who we partnered just recently, and together we built a mixed reality case where we connect the car to the mixed reality. We provide the driver and passengers with the headset with the pass-through technology where they can see the real world and the augmentation layer overlaid over their eyes. The car is reacting to virtual objects that may appear on the road and reacts to various traffic situations that we can simulate inside the XR. Tesla Suit is an important interface here where it helps us reading how the users are behaving in different situations, whilst the car is reacting to traffic collisions or near miss situations and so on. Honda Robotics is another good example of our collaboration, where Honda will be using our suits and gloves for training the robots for product testing, for example, actually training the robots to behave like humans. And in many ways, with the Tesla glove, we will enable the remote manipulation and telesensing as well. ESA is another good example where we partnered with Stardust Technologies on a project where we're building a simulation that can be taken on board of the spacecraft. The European Space Agency is a major sponsor of this project, and we're now going through a 3-phase study on the human body and body reaction to microgravity, EMS intends in microgravity, and we're trying to assess the psychological state of the potential astronaut so we could provide full telemetry back to the control center. We could also mitigate difficult circumstances when somebody's traveling for a very prolonged period of time and yet needs some assistance. Where we work with enterprise market, Schlumberger and DTEC are good examples of proof of concepts that we've built together in safety training and critical situation assessment control. Where, as far as Schlumberger is concerned, we built what's called low frequency high impact event system, and this system helps us to train the speed of recovery from a stressful situation and regain operational control. Whereas DTEC was looking at ways to introduce full training, also walk the employees through a disaster so they could better understand how to do the maintenance and what consequences there may be should they make a mistake. All of these interfaces are very new, yet we're looking forward to its expansion, and hopefully the training will move to a digital domain where it will save us operational time, money, and will actually greatly expand what we can do within the training environment itself. This concludes my presentation. I hope you liked it, and I'm open to your questions.
I take the opportunity, Marco, to remember our audience that you can use the live chat and platform to submit questions to our guest speakers. Keep on, Marco.
Thank you. Hi, Dimitri. Can you hear us?
Hi, everyone.
Hi. It's a real pleasure to have you as the first digital guest in this beautiful theater in the heart of Bologna. If you agree, I would like to start this Q&A session with a simple question.
With pleasure.
Your product seems to anticipate a scenario where haptic perception over the whole body could become a device for remote interaction. How do you evaluate this market growth, and how do you imagine making experience design accessible to as many designers as possible?
We see that the haptics is picking up the pace, and many companies, we're working in the B2B sector for now, but we see that many companies are now realizing how important the haptics is for any virtual environment. For one, it helps maintaining the focus of the brain within the virtual environment and keep it immersed. Because the moment we fall through the texture, for example, of the virtual world, the brain quickly disconnects from that reality and sees it as the augmentation instantly. So this is where we see that haptics is going to be only becoming more and more important in any type of interaction. Plus, on top of that, it helps saving a lot of time, because when we have the physical constraints inside the virtual reality, it helps us navigating much quicker and better, and it provides a more familiar interface, as in we are very tactile in our real world life. We like touching things. When we're babies, we learn through touch. So that's the basic instinct that we train throughout many years before we become visual, mostly. So and then the way we basically are looking at delivering our products and delivering the haptics to the rest of the world is we're building partnerships we're building academic programs to help placing our products inside universities, inside the labs, so more and more people can get their hands on it and start thinking virtual with physical interaction, kind of thing.
Thank you.
Good morning, Dimitri. Andrea Cattabriga here speaking. Designer, PhD fellow here at the Advanced Unit of the University of Bologna, here to link you with our audience. We got one question for you, just a quite technical question about an possible application of your technology. And yeah, the question is, do you see a possible development where it could be possible to take advantage of the characteristics of your suite applied in high-risk working environments?
When we're looking at high-risk environments, the most important is that any user activity, when the person is leaving the virtual space and then is supposed to act in the real space, when we're talking about critical has to be taken with what's called subconscious decision-making. And the haptics, and in fact, the skin itself can talk both to conscious part of the brain, but also to the subconscious part of the brain directly. So it trains our almost like responses, which can be then triggered automatically. When we don't even need to think about what we're doing, it's all going to be based on a reflex. So when we're talking about when we immerse ourselves into critical situations, and especially the more critical it becomes, the brain goes lower to basically our instincts. And if our new instincts are to be safe, to make ourselves safe in a specific situations, it only helps going through that without a mistake. So this is where haptics is ultra important. On top of that, our electrical stimulation haptics is even better because it touches directly the neural connectivity. So, and it works both with the spinal cord and the brain, physical part of the brain. So this is probably the fastest route to train a new skill for those environments.
Quite interesting. Got another question from Camilla Gironi asking, thank you for the great presentation. Is there any possibility to see an application of Tesla Suite's full body haptic fields as a tool for explainable artificial intelligence?
I would say so, because for starters, to train the artificial intelligence, for instance, to understand the human body, we need enough samples. And with Tesla Suite, the sampling itself becomes standardized because every sensor is on the same place on every human. We also provide physical motion, so secondary part to the data flow. So we need to understand whether the person is actually moving or not moving, for instance, to even understand why the level of activity, for instance, and biometrical sensors are outputting specific type of data. So that correlation is an important stream of information just to teach the AI. Then when we're talking about real application cases, for instance, Volvo itself, as well as Honda, have used our products to train what's called randomized human behavior patterns to the computer, because you know how once the algorithm is written for the computer, it will repeat it so perfectly that one can distinct that this is the machine that's doing the movement. Whereas in Volvo case, for example, it was all about product testing for humans, and therefore their robotic equipment was too perfect, and then the product would fail on with the human, you know, in the system. So they needed something to feed the computer that there's a level of randomity to show the delta of variation. So they just simply put the suit on, played multiple scenarios with multiple people, recorded it, passed it over to the machine to analyze, and that was it. Presto.
This looks like opening a room for expanding a Turing testing to physical externalization of AI. It's quite fascinating.
Indeed.
Thank you.
Thank you. If there are no further questions, we would like to thank you so much for your time and for your attending in our symposium. Thank you very much. It's been a pleasure. And now we'll leave the floor to Professor Michele Zannoni for the next speakers. Thank you.
Thank you.
Thank you, Marco. I lack some information about Marco Pezzi. I said that Marco Pezzi is a research fellow of Advanced Design Unit. I wrong because Marco Pezzi is a research fellow of CRIC, and thanks to CRIC that he is involved in this project. Thank you. We pass to the next speaker. The next speaker is Leonardo Giusti. Leonardo Giusti is a head of design project Soli in Jacquard at the Google ATAP. And he talked about in this presentation about the role of the AI, artificial intelligence, in the design process. If we are ready, we can start.
Hello everyone, my name is Leonardo Giusti and I'm head of design at Google ATAP. Google ATAP is a research and development lab in Google devices and services. We are a group of engineers, scientists and designers that work together since the very early stage of innovation projects. And today I'm going to talk about one of them, Soli, Project Soli. Well, how many times you have walked into a building and someone has kept the door open for you, even if you don't ask for it? It happens all the time because as human, we have this sort of implicit understanding. And this feeling of being understood without saying a word happen all the time between people, but it never happened with technology. So what if we could experience a similar feeling when we interact with a product? This is in the end the problem that we're trying to solve with Project Soli. Can we design interaction that feel human? But let's start from the beginning. What is Soli? Well, Soli is a miniature radar sensor, a tiny, tiny sensor that understands human motion at different scales, from finger motion to full body movements. And it took us about 5 years to shrink this, radar technology in a chip that can actually fit into consumer electronics, and to develop the software to interpret these complex human movements, starting from the temporal variation detected in the received radio waves. Why did we pick radar? Because radar has some very interesting property for consumer products. For example, it can operate at very low power. It can be very efficient from a computational point of view. This allows us to create sensing system that can be always on, even in battery-powered devices. Then it works through material. So this is a good news for industrial design, because now you can create product that don't have any holes on their surfaces. And of course, it's a more private, than cameras, because it doesn't capture any visual image. It's also really robust. It's not affected by changing in lighting or temperature. It works during the day or at night in the same way. So this unique characteristic of radar unlocks some very interesting design opportunities. When we started working with radar, at the very early stage, we focused on microgestures. And we discovered that Soli can be used to detect sub-millimeter motion at the finger level. On the bottom left animation, you can see a range Doppler visualization where you can distinguish both two hands moving up and down, as well as two fingers quickly moving up and down. And on the right side here, you can see a prototype that uses machine learning to interpret this signal and actually create a knob-like microgesture. However, very soon, we also discovered that with the same sensor, with the same chip, we could detect Also larger movements, such as, for example, people walking around. You can see how in the left bottom image, it's actually a visualization of the raw signal, and you can see how you can detect people moving away and closer to the device. And on the bottom right, you can actually see a machine learning model that has been trained on that signal to understand when someone is nearby a device or not. So this is an exciting opportunity because with one single sensor, we can now create a new input method for consumer electronics that works at different scales, from micro motion to larger movements. And thanks to radar and some advanced machine learning algorithm, we can now interpret small and large gestures, as well as like body language expression, like, oh, I'm leaning toward a device, or I'm walking toward a device. And spatial relations between people and devices, like as simple as someone is nearby, or more complex activity patterns, like social context, and so on. So it's based on this observation that give us the idea to actually frame interactions with radar as non-verbal interactions. And we use these sort of like non-verbal communication cues every day. In our daily life, we use distance, body language, and gestures to mediate interaction with others. But despite the opportunity presented by our intrinsic understanding of these forms of communication, they have been rarely used in consumer electronics, mainly because of technological limitation. So with Soli, we want to create a new interaction language based on the continuous understanding of nonverbal communication cues. Over the past years, we have created a library of what we call interaction primitives. You can think them as pseudo API that can be standardized across a variety of products. For example, we have swipe and tap as two interaction primitives for gestures. You can have like approach or lean as interaction primitives for like body language, and like presence or the user status, is the user sitting, walking, as sort of like interaction primitives in the group of spatial relations. When you start putting these interaction primitive in the context of product design, they actually change the way we can think about the interaction with products in two main ways. First of all, they add natural gestures to existing input methods, such as voice and touch, opening the way to truly multimodal interactions. Secondly, they extend the relation between people and products beyond the direct active interaction, beyond direct manipulation. Thanks to Soli, now products can be aware of what is happening around them and actually anticipate the user intention to initiate the interaction. If you think about that, that is very similar to the way we interact with each other. Like when you enter a room, you are aware of the people around you, but you're not actually paying attention to them. However, if you want to initiate a conversation with someone, you need to first get their attention and then to start the conversation. So with Soli, we basically use a very similar approach to design interaction with products. And in these diagrams, you can see how our interaction primitives map against these new product states. Let's make an example. Imagine to have a home display like the Nest Hub. Because of Soli low power capabilities, it can stay always on and scan the environment to see when someone is nearby. If there is a notification, let's say about a delay on your upcoming flight, the device may decide to avoid the delivery of that notification at that specific time because no one is nearby. But then, when presence is detected, the device switches to the aware state. And now it may make the decision to actually deliver the alert because there is actually someone nearby to receive it. And in this state, the device can start looking for cues regarding the user intention to start the interaction. For example, if the user approached the device, like walking toward the device could understand this cue and expand the notification, reveal more information to the user. In this engaged state, the device can start listening for gestures. And now the user can easily dismiss the notification with like a swipe or take an action with a tap. So by introducing nonverbal interaction across Google portfolio, our goal is to create a new generation of product with social grace. Products that are not only intelligent, but also considerate of others, of the context around them. I want now to actually dive deeper on one of these interaction primitives to show what it takes to bring a vision into a product that ships in millions of units. When we start to work with radar as an input method for consumer electronics, there was no precedent in the market. And as you can see, it is really hard to build an intuitive understanding of how it works. So we literally had no idea of what would work and what wouldn't. So as designers, what we started doing was to run a series of studies, of interaction study, to get to know the material qualities of this new medium we were working with, even before start thinking about use cases and application. This is just an example, of course, but where we took a picture of the hand every time the radar reflected the same amount of energy. And then we superimposed these pictures. And this is the result. From this, we learn, for example, that a finger nearby the radar reflects the same amount of energy than your palm at distance. So, for example, the same gesture is actually seen differently from the radar point of view at different distances. And you can use this in your design, for example, to have the same gesture have different meaning when it's done close to the device or farther away from the device. We also started to build a simple interactive visualization so that we could start experience firsthand the relationship between movements and the feedback provided by Soli, and really learn about latency and responsiveness. And then over time, we start building more advanced prototype using mixed techniques such as heuristic-based algorithm and simple shallow machine learning models. Ultimately, we define a set of hypotheses, that make sense both from a technological and a user point of view. And we went out there and test them with people. We actually ran a study, an international study with more than 10,000 people across 13 countries. We really wanted to understand if this gesture had different meanings in different cultures. And so we went out there, we present these gestures to different people, and we discovered that independently from the device where these gestures were executed, there were some sort of like universal principle. Gesture with a motion, a main motion that was perpendicular to the screen surface, were often associated to actions, like pressing a button, for example. Gesture with a motion that was parallel to the screen were often associated with content manipulation, like vertical scrolling or horizontal navigation. And so we decided to organize our gestural language around this spatial model to make it easier for people to remember it and learn. And so we end up with two main gestures. Tap to take action, as it happens in the vertical plane, respect to the sensor, and swipe to move things around, as it happens on the horizontal plane, respect to the sensor. And these two gestures have been shipped in different products. As you know, discussed before, in Pixel 4, swipe were used for music navigation, dismissing alarm, and phone calls. In Nest Hub, we use swipe to snooze alarm and notifications. In the same way, the tap gesture was used in Pixel 4 to play and pause music, and the same use case was also applied to the Nest Hub that we just recently shipped. But how does it actually work? once you have the gesture set and some initial prototypes, you're just at the beginning, right? The gap between a working prototype and an algorithm releasing millions of products worldwide is actually pretty big. So how did you get there? Let's take a look at the Soli software pipeline. The raw signal, as you can see in this diagram, is captured by the antenna of the Soli chip. Then different signal digital processing techniques are used to transform the signal in a format that is suitable for machine learning models. In our case, the range Doppler complex. Then we apply machine learning models to detect and classify these gestures. Here you can see on the left how the signal look like as an input of the for the neural network. You can see how it changes when a user performs a swipe. What you see there is a range Doppler. And on the vertical axis, you have range, and on the horizontal axis, you have velocity. You have positive velocity on the right and negative velocity on the left. And so we took a screenshot of this visualization that you can see on the right side of this slide. And you can see on the top row, it's a very clean swipe. You can actually see the hand moving away from the body, getting closer to the sensor, increasing the velocity, slowing down, and go back nearby the body. But then if you look at row 3 and row 5, the signal is not as clear. These are still swipe gesture, but especially in row 5, you can see that it's really hard to detect the hand because the user in this case was performing the gesture very close to their bodies. So if you have to teach to a machine learning algorithm to recognize what is a swipe in the continuous flow of data that they receive, you need to show the neural network a variety of examples of what a swipe is. And you need to capture the variety of all possible swipes. Like, for example, close to the body, farther away from the body, with the hand in this position, with the hand in that position, and so on. Because in the end, you want to be sure that the algorithm actually works in the real world, where people will perform this swipe in every possible way. And so a big part of this process is actually data collection. To simplify it a lot, you need to collect examples of swipes done by different people with different variations. We call these positive cases. But you also need to show the neural network what is not a swipe, even if it looks like a swipe. These are called negative cases. And on the bottom right, you can see an example of that. This became sort of like an iconic example that we keep referring to in our process. We call it the coffee cup test. From a radar point of view, that motion is very similar to a swipe, but it's actually not. So the neural network needs to distinguish that motion from an intentional swipe. And you can do that by showing it a lot of examples of real swipes and what we call, the negative cases that are designed to trick the network.
The coffee cup test was just an example. In order to have enough coverage, you have to try and define a larger set of test cases that cover a variation of movements in different contexts and so on. So in the end, we end up designing more than 300 test cases for the data collection. And we collect data from more than 7,000 participants in 9 different locations across the world. We end up collecting 500,000 of gestures and more than 285 hours of negative recordings. So this massive data collection with some advanced machine learning technique allow us to achieve the performance that we needed to ship it into a real product. Ultimately, you want to have a machine learning model that have a high detection rate. Every time you do a gesture, it should be recognized as a gesture, and a low number of false positives. Where you're not doing a gesture, it shouldn't think that you're actually doing a gesture. And on the graph on this slide, you can see where our model was positioned. You really want them to be on the top left corner of this graph. So going back to our initial questions, how can we design interaction that feel human? I believe that the interaction model that I presented today, supported by Soli, is a step in this direction. Over the past years, we shipped some of these components in different Google products. For example, in Pixel 4 in 2019, we shipped the swipe, tap, gestures, the reach, and presence. More recently, in the Nest Hub, like a few months ago, we shipped the two gestures, swipe and tap, and a new building block, sleep sensing. It's a very exciting new feature that it will probably deserve another talk to actually describe how it works and what it is exactly. And finally, in the Nest thermostat, we ship presence for room occupancy. So it is, of course, our aspiration to make this interaction model, this new interaction language, part of the entire family of Google products. However, this framework is also important for us internally. It is a map that we use to establish a common ground between engineers, scientists, and designers so that we can communicate together. It is in the end a guide to orient our R&D effort toward the discovery of new interaction primitive based on radar technology in a way that is consistent across the different disciplines. Thank you very much. If you have any questions, please hit me at ljusti@google.com. Thanks.
Hello?
Hello.
Can you hear me?
Yes, I can hear you. How are you?
Hi. Hello, everyone. I'm good. Thank you. And I'm sorry I'm not on camera, but my internet is really, really bad over here. So I have to take this on the phone.
Yes, I know, because Leonardo gave the confirmation before we change the original data of the symposium that was in May, but we have to change for some medical problem that the staff have got. And now Leonardo is in vacation, in holiday, and cannot connect to the webcam and is connected with the mobile phone, but is here with us. I start with a simple question. In the first part, in the introduction of the symposium, I speak about I speak about the role of artificial intelligence, and I speak about of the implication that TensorFlow library is carry on the design process, and I speak about is important and relevant a complexity that the designer can't control. There is a big gap with the use of the artificial intelligence to create a relation with the body and the ordinary ether of the design flow. And what do you think? Is possible that this gap will be reduced in the short period, in the short term, or remain a gap that control only the big company, or is possible that will be create some application that simplify this process to teach about the AI for create a new project that are for the everyday things?
Yeah, I do believe there is a trend where a new set of tools are becoming more and more popular so that people, designers, can just, start using them and create their own algorithms. But the problem with machine learning, and for example, there is products that are like already available, like Runway, for example. I don't know, it's not a Google product, it's another product that everyone can use it, and there is a lot of data available there, like GP3. There is like a lot of computer vision data available, and it's mainly used by artists right now. but it can be very well used by anyone to create different types of application. So there is a trend, I believe, to make this tool more and more available. But the problem with machine learning is that to make it truly open sources, you have sort of three main considerations to make. The first one is the tools and the framework. And with TensorFlow and TensorLite, they are already available. You can use them. You can use the power of Google Cloud to train your model, right? And then with TensorFlow Lite, you can export your algorithm in a very optimized form that can be embedded already in a device. And that's there, and is getting better and better over time and available to everyone. The problem, though, is not just the tools and the framework. The problem are the data itself. The data are very expensive, and it takes a lot of time to collect. And in computer vision, for example, because it's an older field, right? You have 20, 30 years of history. There are a lot of databases that you can use to train new models. With other technology like radar, it's just starting, so you really don't have this data available yet. So the other important area here is to understand how to make this data available for everyone. And on one hand, there is the brute force approach, where you just collect huge amount of data. But recently, there are new techniques in machine learning called data augmentation that allow you to take few data and augment them, multiply them using certain techniques, so that you don't need to collect this huge amount of data like we did for Soli, for example. But data is still an issue that till you have enough people working on it, till they are made open to everyone, you still don't have them. And finally, there is the model itself, the algorithm itself, that it requires a lot of knowledge. There are certain model architecture, for example, for computer vision again, that are available, and you can use them for different tasks. But for new input technology like radar, these architecture are radically new. And the one that we are developing now at Google are, we just published them. There is a paper we just published at CHI. You can go and look at them, but they're not yet publicly available. But that's our desire anyways, to make these models more available to everyone so that people can actually try them. So think in terms of reducing the gap, I think tools and framework, amount of data, and make this model available to everyone so that people can train them for different tasks. These are the steps that are necessary in order to make it more approachable.
Thank you, Leonardo. I pass to the over answer.
Good morning, Leonardo, Andrea, colleague here with Michela. I bring you some questions from the audience connected on our online platform. First question from Fabio Pretini is asking, thank you. I was wondering at which maximum distance the radar is still able to detect, for instance, the presence of a person.
So it really depends on the radar settings, and which depends on the power available to the device. But in a plugged-in device, you can detect presence till about 6-8 feet. Meters. Yeah, 6-8 meters. On a mobile phone, which is battery powered, it has to be a little bit. It's less. It's about 1.2 meters. But with the current settings and hardware, we can push it to about 8 meters.
So that's opening the room for a collective interaction to this technology. It's not just personal interaction. Quite fascinating.
Yep.
There's another question for me, more about the perspective of this technology. And we talk about how to manage machines and the technology stacks to interact in new ways with technologies. But I'm wondering, if you believe that the mass adoption of non-verbal interaction technologies could influence our communication capabilities, that's happened with text messaging, the use of text messaging, social messaging. We shortened our definition, we shorten words, and we are some scholars are observing that people take this language deformations and bring them into the real world, not only when interacting with technology. So what's your perspective on that?
Yeah, no, that's extremely interesting. I do believe that, our effort, of course, is to take inspiration from the way people already interact with each other in the real world and try to understand those behaviors. But, from an technology evolution point of view, I do believe that eventually people will also adapt their behavior to be understood by technology itself. And this is often painted as a bad thing. And personally, I don't think it's a bad thing. I think it's an evolution of language. In the same way we adapt ourselves to use emoji and other forms of communication, I do believe that also our nonverbal behavior will change to interact with machines, and they will become part of the fabric of everyday life. The same way we interact with other people, we will have a sort of like code to interact with machines as well.
Thank you so much for being here.
Thank you, Leonardo.
Thank you.
Okay, I come back to the stage. On the stage, Professor Roberto Montanari, that will present the next speaker. Thank you.
Thank you very much, Michele. And thanks for being with us for this exciting day on the human-body interaction. So it's time to talk about the emotion, as mentioned in the morning. And I'm very glad to have with us an experience which is very interesting and important. I mean, the emoji experience. We have with us Maura Mengoni. Maura is associate professor at the Polytechnic University of Marche, which is a very crucial technical, let's say, and academic center in the center east of Italy. And Maura is also president of a spin-off of the university, which is called Emoji, and is focused on the emotion tracking. So they develop a very exciting technologies for tracking the emotion. So she's presenting us a speech titled Emoji, a new design approach to create engaging experience from emotions. So the floor is for the speech.
Good morning, everybody. I'm Maura Mengoni, Associate Professor and Co-founder of Emoji. My today's speech will be focused on storytelling the Emoji Foundation and to present you our new design approach. First of all, I would like to show you some important challenges that trigger out our research work. There are several situations where the success of a product, a service, a system, or a public space depends on the emotional reactions people have while interacting with all of these cues. Imagine a supermarket shop. Why does the customer choose a specific product than another one? Or why does he leave without buying anything? It could depend either on the market layout, the product package, price, or maybe on the employee's courtesy when provide the service. Transfer the situation to a digital shop. Some customers appear frustrated during the navigation and leave the e-shop without checking out. A museum is a public space where people go to learn something, to be fascinated by the artifacts, to live a cultural experience. However, how many times we have seen people relaxed on a seat, losing interest on the surrounding? It could depend on the fact that the exhibition is not able to elicit their interest, or they cannot find their personalized journey within the museum. Finally, have you never thought about how much emotion affect road perception and driving performance? Is it possible, according to you, to improve the human-machine interaction to increase the driver's attention by regulating their emotions? Feelings as to whether a product deserves to exist or not can only be based on our personal reaction to the values it offers. Consequently, we should have no reason to presume others will share our same reactions. So I think that the first challenge we have is measurement. We as designers, researchers, have to measure objectively and quantitatively the reaction that people have when interacting with other products. As we designers must know who are the customer, what makes them different from the others, and how they feel and what they want. Facilitated by the networking power of internet, consumers are becoming prosumers, taking a proactive role in specifying what they are looking for. Today, the high quality of a product and the user experience it provides are not enough to ensure its success on the market. As a consequence, most companies are making the product only the part of a well-conceived and comprehensive customer experience to guarantee consistencies between all the signals transmitted through every element at every touch point. As a consequence, most Western economies continue to shift from providing discrete products to providing services. Designers have moved their input upstream to help shape the business model of companies and design every touch points where people interact with employees and fabric of the service provider. Therefore, the second challenge we have to face with its complexity of human-system interaction at every touch point. That means to be able to measure the human reaction both in physical and digital scenarios when he or she encounters the company and assign a value to the experience he has lived. Moreover, measurement must be transferred to design to improve the customer experience. We can get some important insight from the huge amount of data to create individualized human experience, to design a better product and provide more satisfying services. So, our research goal is the creation of a unique experiences to engage and connect with customers, able to transform their feelings from negative to positive, to intercept their wishes and respond in real time to make them more satisfied. We try to achieve this goal by defining a holistic approach and an implemented technological framework that's based on 4 different steps strictly interconnected each other. At first, we want to analyze all human system interaction at every touch point, use this data to know some important metrics to assess the customer experience, and then decide and react in real time to change the human state and realize a pleasant, engaging, and personalized experience. In 2017, Emoji was born as academic spin-off of the Polytechnic University of Marche with the aim to implement this approach and transform the world of customer experience. We were a team of 5 researchers and visionary businessmen with a dream to become in the future leader of customer-centric innovation by providing challenges technologies, most based on artificial intelligence, to automatically measure the complex human state and create adaptive customer experiences. Today, we are a team of 10 experts in artificial intelligence, pioneers in affective computing. This is just an overview of the technological progresses we did in these years toward the complete assessment of the complex human state and its use in creating adaptive experience in physical and digital scenarios. The system is based on 3 different software modules interconnected each other to realize a continuous flow from analytics to real-time adaptation. We were the first in Italy to develop a face coding system based on deep convolutional neural networks, enabling the recognition of age, gender, the 6 primary Ekman emotions, valence, engagement, gaze direction, and other indicators from pictures and videos captured by every type of camera. The huge amount of data are then collected and arranged into a web analytics dashboard where it's possible to know the degree of attention, the satisfaction rate, engagement, customer profile, and its reaction to specific cues at each touch point. When a second camera is added to the environment, the emoji system is able to detect body movements and postures to identify the user behavior and assess ergonomic factors, as you can see in these slides, where we are able to identify some awkward postures in order to support the improvement of factory operator safety. Emoji operates in numerous sectors, from fashion to automotive, from museum to entertainment. For the technology, scalability, and configurability. And I want to show you just some example of to demonstrate the applicability of our approach. The first application is the system used for audience measurement during the opera festival. Infrared camera were positioned in the Stereo Arena to detect the audience facial expression during the show. Collected data were elaborated to identify an innovative model or relationship between emotion, satisfaction, and appraisal, and address artistic choices to improve future performances. The technology can also be embedded in mobile app and website to monitor the user experience and automatically find the usability issues. It tracks users' interactions, plotting aids, find heat maps, assess satisfaction rate, and completely map the user journey. Today, analytics only answer what, while our system can answer also why. Once the system has recognized the person's age, gender, emotions, and in some cases identity, it's able to adapt the user experience based on his or her state in order to realize a sensible, reactive, and personalized environment. The application you can see it in this slide is an emotional tunnel sensed by multiple cameras and equipped with LED lighting, LCD display, video projectors, audio speakers. When a person enters the tunnel, it's recognized and a customized experience is offered by changes in real time different sensorial stimuli. The second application is a multimedia totem for museums equipped with a webcam on the top. When visitors are in front of it, emoji assign a specific cluster to this type of visitor and propose a journey across the museum through the visualization of different artworks. In automotive, we are developing UDrive in collaboration with Relab. UDrive is a driving assistance system that regulates the driver's emotional state to increase safety and comfort. We launched it at past CES. The last year was difficult for most of us, but Emoji takes the opportunity of COVID to study and launch a product line dedicated to distance learning. Coursing Cloud is a learning platform for the delivery of compulsory professional training courses. It monitors in real time the identity presence of all the attendees, the level of attention, satisfaction during the video lecture, and automatically produces the certificate in compliance with the GDPR. Examine Cloud is a spy software with a lockdown browser to check that students are not copying during the online exam. Eventing Cloud is a live event monitoring software that measures real-time the engagement rate, satisfaction, and the interaction level of the host user in conferences, seminars, and meetings. There are just the name of some of our customers and partners which have allowed us to be leaders in artificial intelligence. Just some concluding remarks. The today's scenario has rapidly changed to adapt products, services, and experience to the customers. This makes it imperative to introduce human factors in design and human-machine interaction. Internet of Things, artificial intelligence are just enabling technology to achieve this goal, but their implementation requires an holistic approach and, yes, a design vision. Emoji was born to take the opportunity of the upcoming digital transformation to contributing in creating a world of emotional intelligence. Emotion, I believe they have a power to connect us with us, but also to realize an empathetic connection with the object, with the spaces, and so to improve design. Thank you for your attention.
So are you there, Maura? Are you connected?
Yes, of course.
Hello.
Hello.
Welcome to our symposium. And thank you very much for the great presentation you gave us. So just some questions, of course. One comes to me. That is the first, then I leave the floor to Andrea for the next, for the public. Just curious, you did a great overview about the type of applications that you have done with your technologies. So I'm wondering, and the question is, which is for you the long-term perspective of the emotion tracking? So how do you see in the long future, in the future scenario? I guess it's not an easy question, but which is the future of the emotion or the emotions tracking?
Yeah, thank you for the question. I think that the long-term application could be automotive. And I mean, automotive and all sectors where a person strictly interacts with a machine. For example, motorcycle, robots, yacht spaces. So where it's, I think it's necessary an empathetic connection with the machine. Till yesterday, I think that we have just a cognitive interaction with machines. Today, thanks to emotion recognition, we have the opportunity to interact with them in a humanized level. So the long-term one, I think it's, yes, automotive and this type of sectors.
Thank you, Maura. So understanding the emotion make everything more, at least the interaction with technology is more human. And as being human is part of being a body. So I mean, that's a strong relation with what we say today. So Andrea, question, I guess, from the public.
Question from the audience. How do you think the interaction between body devices will change as we will be able to recognize emotion in real time? And the second part of the question, what are the guiding elements of the interactive design of these systems, considering that we can intercept the user's emotions?
Complex question. I think that the great effect of emotion in design is the changing of the paradigm of product design. Because we are used to think about product design, we are used to think about the performance, the technical performance a product has to provide us. Emotion can change the role of the product in our lives. Emotion, but also body tracking allow product to be more interactive, more adaptable as. So the product becomes a sort of service, a service that contributes to our well-being and to respond to our implicit needs. So I think that a designer has to change the way to look at the product and look at the opportunity of emotion and body tracking to make their product a sort of services. I think that this is just the great paradigm.
And to conclude, which advice will you give to policymakers handling this quite privacy-related question of having people, having someone getting data from the interactions in public events?
I just to answer with what a Google director answered me when I make this type of question. He said that privacy today is an opportunity and not a limitation for all of us. I mean, DGPR was a complex event for my company. We have a stop for I think 3-4 months where everything where our customers decided to stop to work with us. When we are Italian, so we are European people, so we study the problem and then we find a solution. So today we work a lot on developing cloud infrastructure to manage privacy and other biometric data in order to ensure the privacy of our customers, of their clients, but as well as to use this type of data to generate more satisfying services for one people are available to spend money and to spend also their pictures, videos to got it.
Thank you so much for being here.
Thank you very much, Maura. Thank you
for your invitation.
Thanks again, Maura, for being with us, and enjoy the rest of the day. And thanks also for your presentation.
Thank you to everybody. Now we make a pause for 10 minutes. If we come back to 12. Thank you.
Thank you for being with us, and see you at 12 on time. Thank you. Hello, welcome back to the HBI Human Body Interaction International Symposium. We are very happy to be here. And now it's time for introducing a project which have the ambition, let me say, to give the real feeling of the dance in virtual environment. So I'm very happy and glad to have here with us the colleague from Alto Balletto, which is one of the most important, let's see, experience and organization aimed at promoting the dance and creating new, let's say, aesthetics performances in the area of dance. So I'm very happy to have with us Fabio Ferretti, which is a project manager at Alto Balletto, and in particular the development of special projects. And today we have a very special project. So Fabio, thanks for being with us.
Thank you, Roberto, and welcome everybody. Hello, everybody.
Hi, Fabio, welcome. Okay, so I guess that there is now time for showing a video, which is a very quick overview about the experience that you want to present to us, virtual dance for real people. And then we have to make a kind of experience. I will take the role to experience something, and you will guide me in this kind of virtual environment. Yeah, so if my colleagues from the backstage agree, we can start with the video.
Il periodo dell'emergenza ci ha spinto o costretto a trovare nuovi modi tradizionali, come può essere lo streaming, già più elaborati artisticamente, come sono le videocreazioni, o addirittura connessi a una ricerca assolutamente innovativa come quella della realtà virtuale.
Quando ci è stata lanciata la sfida tecnologica di utilizzare delle tecnologie di realtà immersiva, abbiamo fatto quello che facciamo di solito, cioè abbiamo indagato tra le tecnologie che potessero essere, come dire, candidabili a questa sfida. Quella della Cinematic VR è stata, a nostro avviso, da subito un'ipotesi interessante.
Ed è una splendida occasione per mostrare questa potenzialità della smaterializzazione del corpo connessa alla separazione tra due dimensioni che fino all'epoca predigitale erano sempre in realtà invece accoppiate, incollate, cioè quella della localizzazione e della presenza.
Provare a far convivere nello stesso spazio il danzatore e lo spettatore, e che questa interazione possa essere almeno forte o anche più forte ed emotiva di quella che avviene frontalmente in un teatro.
L'immersività effettivamente in questa formula è una chiave nuova per vivere l'esperienza della fruizione della danza, e lo è sia nel fornirci emozioni forti, allora anche perturbanti, ma anche emozioni per così dire più immersive.
Fare un processo di ricerca e di scrittura coreografica nella quale lo spettatore è già integrato ed è già parte della ricerca creativa dell'artista.
Here we are again. So Fabio, thanks for this great video, and which highlight the project. So I will leave the floor to you because I have to dress something to take the device and try to let you see and our public see how the system is working. So please say something in while.
All right. All right. Thank you, everybody. It's a real pleasure for me and a real pleasure for us to be here and to make with you this experiment in order to share this experience we create together with Relab and Riot Studio 2, which I have really to say thank you. Some very quick words about who we are. We are a dance production center. We are funded by region Emilia-Romagna and the city of Reggio Emilia and the Italian ministry, and our goal and our main aim is to produce dance, Italian dance, international dance, and present it in the best situation we can. We are based in Reggio Emilia, and what you are going to see, going to experience in this strange and new ways also for us, as the result of more than 1 year of work. Of course, it was something which was thought and created during the very hard time of the beginning of the lockdown, where we were faced to the impossibility of doing our work, of present our shows. We are normally a touring company, so our main company, which is named after Balletto, normally creates and present more than 150 shows every year. So as you can understand, 1 year ago, we were in the situation of no more presenting any shows. And we need to face this new reality, and we needed to somehow find a solution and think about how, through technology, we could overpass that situation. As you saw in the video that was said by my director and our colleague, we decided not to go for the first and closest solution, as it is the broadcasting. You know, taking one show, broadcasting it, putting on the internet, and making the audience attending it. That is the easiest solution. But as you may understand,
sorry for interrupting you.
All right.
The chance to dress the oculars, the visors, and I'm in a space. So please guide me. I guess that our public can see.
Okay. So one premise is that normally it is not normal to make a comment on a live performances, especially of a dance performances, because a dance performances normally has an emotional connection, present an emotional connection between the spectators and the artists, the performances. But now I have to do that because this is the situation, and this is an extraordinary, so something not ordinary performances, because it's something which is a performances, but it is not live. Roberto is looking at performances that was the result of the process I was presenting just a while before. So now through an Oculus, through this VR Oculus, Roberto is within a space, a very specific space, particular space. It is a old chemistry an 18th century chemistry situated in Ago Fabbrica Culturali, which is like a cultural center in Modena. In this space, which has been quite renovated, now you may see it totally transformed by a scenography, by some set and props, and by a performances, which is happening right now, and Roberto is attending it. So you may see these two beautiful and very talented dancers named Kasia Benkoichea and Annemieke Moji, who are dancing, and Roberto is experiencing a totally different and uncommon situation for a spectator. The live performances is normally and very basically understood as something that happens now and here. So in a space and in a very specific moment. And this situation, this specificity brings on that emotional level, here we are, through the eyes of Roberto. And this specificity, I was saying, is the one that creates this emotional connection between the spectator and the artist. But now, as you can see, it may exist the here, the space. Roberto is through the oculus in a space, this old chemistry. Of course, this is not happening. So there is not now happening. This performance was recorded through a cinematic voir camera, was recorded once, and was recorded 3 months ago, and it was created by Diego Tortelli, who is a very talented and young choreographer resident in our space in Dance Foundation Reggio Emilia. And he created this choreography, bearing in mind to have the spectator inside the stage. So the main experiment we worked on during this year was to change the perspective, to change the relationship between the spectator and the artist. No more the spectator is seated comfortably in an auditorium, is in a distance, so looking from 15, 20 meters away what is happening on the stage. But in these performances, the spectator is inside the stage, and the performances is created thinking on that, thinking on about the presence of the spectator within the stage. So this you are looking at is the third experiment we did during this year. We created this kind of recorded and video performances. I was saying that these performances was the third we created after some experiment. And we decided step by step to get into this immersive experience that could bring the spectator within the stage, within the scene, in order to have again that emotional feeling I was speaking at the beginning. So as I can say, this virtual dance for real people wants to create a different experience, experience of a live show, which is not live, no more live, but can belong after a live show. That was the result we got to 1 year ago when we started to work on this. How the technology can help the live arts and the live performances to create something different and to exploit it, to make it bigger somehow. We decided to take this kind of route, this kind of way, and we tried to have the idea of, okay, now we can't do the live show. We could do the live show again after the lockdown, and it would be a long process, step by step, small audience, maybe getting bigger step by step. At once, we will need to disseminate much more our live performance, and this is a result. This is a possible answer. So having one trace that can belong after a live show. This is what Virtual Dance for Real People try to answer, and at the same time, it tried to create a different experience for the spectator, which is always a spectators. This is something very important I want to underline. We do not want, we do not aim in this moment to modify the relationship we have between the artist and the spectator. Not because it's not fair, but it's something that we believe that in the artistic creation, the artist makes a first proposition, the spectators need to trust in it, need to accept it. He can also refuse it, but he can somehow trust in it, and he can choose or not this kind of proposition. So we want to propose the same in a parallel, the same model also for this experience. So the spectator makes the spectators. So he looks at, he moves, he chooses the point of view, he sees something that normally comfortably seated in auditorium he could not see. So he has an augmented experience, but definitely he remains a spectator. He doesn't become a gamer somehow. I'm not saying that tomorrow, in another moment, we could not get to that possibility, but making the spectator becoming a gamers could mean also that the spectator can somehow modify the performances. And so this is another level of creation we haven't got to yet. So thank you very much for listening at me and attending also this mutual experience, also thanks to Roberto. And if there are any questions, here I am to answer it.
Fabio, I'm very, very thankful to you and to the colleagues that are working in this experience. And I hope to have done well in making the role of the spectator. But I really hope that the people have a chance to see what I have seen that has been a very, let's say, immersive and let's say, being part of the body experience event and scenario. So thanks again, Fabio. Just some questions, I guess, from the public. From myself, I have just one for you, which is the following. As a, let's say, a kind of dance designer team, in a way, let's say, how is in using these technologies solution the most enabling element for making the body part of the experience, even in a virtual experience?
Well, actually, I'm not sure to have an answer about that, but I'll try, of course. The body, of course, is the main character of any of our experiment, and the relationship between body and technology is a very wide field. Of course, you know it better than me for sure. What we can do from our perspective is to try to cross some borders. We have some comfortable borders we have in the artistic creation process, where in the normality, the artist creates for a very specific space, in a very specific rules, in a context quite precise, where everybody has its own role. Technology can create a very interesting, but also, to be careful, somehow new situation, because through technology you can change any kind of these rules and a lot of point of view. So our first aim is to make also creators. I'm not actually a creator, I'm a manager of this process. So our work is to bring somehow the choreographers and the designers to work for the technology and together with the technology, making the body getting in dialogue with the possibilities that technology can offer us. So this is something we can put as a future objective or future goal.
Yeah, thank you, Fabio. I just realized how difficult was this question, but you did great. So thank you very much for giving us this as well. So question from the public, Andrea, the floor is yours.
tough question coming from the public for you. As the performance we just attended has the potential to convey such strong emotions, do you think there are other kind of artistic performances other than dance where this approach could be applied successfully?
Yeah, for sure. Yes, for sure. The only problem with, I mean, it's not a problem, it's just an observation, I can say, with artistic creation is that, artistic creation and technology is that you have always to bear in mind that to get in touch, which is to the audience perspective. I mean, I see lots of very interesting performances, artistic performances, maybe theater, maybe music, other dance. Of course, maybe dance is easier because there's body, there's not the spoken language that can be a barrier somehow, or music can be extraordinary also in connection with the virtual reality or other technology tools. The only problem is that sometimes you can get too far away from the audience. I don't know if you follow me. I mean, sometimes you can create something extraordinary, but the audience is not ready for that. You mean? Our audience is, as I said a lot of time, is normally used to be seated in an auditorium. It's not sure that the audience in general is prepared, is already prepared now in 2021 to be somehow totally involved in an emotionally advanced creation. This test we did, these performances we created, was very important to be presented to the audience, because finally we got a first reaction to the audience and we discovered lots of very interesting things. One for all, audience is not prepared to wear Oculus. I mean, we saw lots of people wearing an Oculus and not moving heads for 7 minutes. Even if the performance is created in order that the audience have to move the head in order to follow the dancers, but the audience is stuck because they don't know what to do. So they ask, maybe, am I supposed to move my head to follow the performance? Can I do that? So this means that there's somehow a lack of basic grammar of using technology and proposing technology in the art. Some museums do that and do that through extraordinary propositions, but for the live performances, you can find maybe some incredible visual shows with projection and immersive tools, and then but at the same time you have the audience who is not moving its head wearing an Oculus. So we have to take in mind this.
Maybe not only that, it looks like that we are kind of reversing the paradigm that we started in the 60s, 70s, where artists wanted to keep in touch with the public and they get toward the public. Now it looks like the technology is habilitating us to get the public coming toward the artist, the other way. Maybe just following up with your observation about the readiness of the public, is that maybe that we are entering a phase where we get room for multiple publics, not only the static one that will keep on attending physical places, as theaters and other physical places will be disrupted from that. So it's not only one scenario for all. It's just bringing diversity for opportunities and multiple audiences.
That's for sure. I was somehow getting just a bigger example, but you are totally right. What I was saying before was the result of the first test we had with Meridiana just 2 weeks ago. As exactly you said, the diversity is very wide. I mean, you have lots of audience not moving his neck or his head, but at the same time, you have other people who wants more, who wants to know more and wants to do more. So they expect maybe to have a much more interaction than the one we propose to. So the spectrum is really, really wide. I'm totally agree.
Thank you so much for being with us.
Thank you, Fabio. Thank you, Andrea, for the question and the debate. And thanks again for your great experience that you show with us. So
thank you very much to everybody. And
have a great day and stay with us. Thank you. Bye.
Bye-bye.
Okay, now it's time for Ludovica. The floor is yours.
Thank you, Roberto. Good morning. I am Ludovica Rosato, and I am a member of the Advanced Design Unit and a PhD student. I'm so pleased to be with you today and to have the chance to introduce our speaker, Jakub Kamecki. He's the technology evangelist of TG0, and his speech is about creating interactive 3D shapes and surface with touch sensing.
Hello everyone, it's Jakub with TG0 here. Welcome to my presentation. So today I'll be speaking to you about creating an interactive 3D shaped touch interface essentially. So this is what TG0 does. We bring touch back. My name is Jakub. I'm a technology evangelist here in TG0. TG0 is a company that has been founded in 2015. Currently the headcount is about 25 people. We have 14 patents for our invention, and let me walk you through it, what we do. So as you've noticed, there's a lot of options in terms of human-machine interfaces. We have voice, we have computer vision, we have touch screens, and obviously the one that is more primal, more natural is touch, and this is where we specialize. All of these interfaces have their benefits, have their downsides. It's really all about context, privacy, what we are trying to achieve in a given scenario. Especially touchscreens have become very prevalent in recent years, and they are an interesting kind of example in terms of human-machine interaction, because they focus your attention on the touch screen itself. We want to take a bit of a different approach, and we want to kind of bring back the sense of touch as a way with interacting with machines, with computers, triggering various functions. And this is what we do. So we create memorable controls every customer can love. So we focus on bringing that intimate and private aspect to interaction. We create 3D shapes, 3D patterns, 3D interactions through touch. So this is an example of what we do. We can detect touch, gesture, pressure, movement, and deformation through using a smart polymer approach. So really any surface, any interaction, and the big advantages of our approach is that we create 3D shapes. There are other various companies that operate in this space. Their limitation is that they tend to be quite flat and uninteresting. With us, you get really this full freedom of design of the shape, of the interaction, and you can really create beautiful interfaces that offer the user, the customer, an exciting way to interact with technology. So here's an example of what I'm talking about. A beautifully shaped, 3D shaped interface that kind of invites you to interact with it. And what we are kind of proposing is for researchers, designers to really think about the form and what kind of function it enables. So this prototype is a window controller. It's just an example we built for one of our customers, and it's also one of the simplest, but also one that is the most fun to operate. So as you can see, you have this kind of protrusion that can be fully deformed, and really the user can interact with it, and it kind of invites them into the interaction. And this is what we do. We want to build shapes, build interfaces that give you this sense of control, of intimacy, of privacy, and invite you to play with them. The idea is that through Shape we can educate the customer, and the time to find the function is lessened, the distraction is lessened. It's a more pleasurable and fulfilling experience for the customer. So our technology is also able to be used as a sensor in of itself, more of a IoT sensor, not necessarily a human-machine interface, but rather something that a user can or it can track a user unconsciously. So you don't operate anything, the material just tracks your performance, tracks your movement, weight distribution, etc. So there are two kind of use cases of our approach. One, the human-machine interface in the most traditional sense, 3D shape interfaces, and then you have this kind of IoT use case where we track the behavior of the user seamlessly. A big advantage of our technology is not only the full freedom of design, but also the intelligent use of the core materials. So we don't add anything necessarily, we don't use in-mold electronics, we just use the polymer itself. So in an automotive sector, in a gaming, PC peripheral sector, accessibility, we would use the polymer that is already there. So we reduce cost, we reduce complexity, and offer designers full freedom of design. Looking at the technology stack, just for you to kind of understand how this works on the back end, from the interaction we go to the hardware, and our hardware is fairly simple. So it's mostly technology that is based on software. The non-conductive A side and the conductive B side, that's something that is purely off the shelf. We use non-conductive polymers, fibers, finishes, so it's really up to you what kind of a finish you want to achieve. Then we have the conductive B side. The conductive B side is part of our offering. We've patented a way how to structure the B side material in such a way as to detect various interactions that I've talked about, and then we use off-the-shelf MCUs, off-the-shelf cap sensors that we infuse or we use to deploy our signal processing and AI machine learning algorithms. Through that data, so when a user interacts with this with our material, that data is being captured by the TG0 API, and then we can detect all of the good things that you see on the right, like deformation sensing, touch sensing, pressure mapping, seat occupation, weight measurement, and various others. It really depends on the use case. It's not an off-the-shelf technology. All aspects of this assembly, all aspects of this architecture are up for discussion and up for modification to your specifications. Another huge benefit of this kind of custom approach is that we can very quickly prove that an interaction works. So because we don't use any in-mold electronics, a lot of our interfaces can be potentially 3D printed. It's really about what are your priorities, what would you like to build, what kind of interaction method you want to enable, and with that we enable the research community, the design community to really play with the idea of shape, of function, and really kind of incorporate it into your products and into your research. One thing to mention, because we don't use any in-mold electronics, we don't use wire, mesh, flex or whatever, we remove complexity, we reduce the the need for rare earth metals, we lower energy consumption, less waste. So, and as the understanding of polymers, biodegradable polymers, etc., advances, we can easily innovate and push our R&D to incorporate those materials into our sensing. So, because we are primarily software-based, we can easily adjust to various materials. So, summing up, tangible interfaces for any function, 3D shape, 3D patterns, and really we want to invite you to build new interfaces, new shapes, new functions that are exciting for the end user. Any questions, feel free to ask away. Thank you.
Thank you, Jakob, for your presentation. Hi, Jakob.
Hi, hello.
Hi. It's really interesting to see new and breakthrough way of product interaction. So thank you very much, Jakob, for your presentation. Now I'd like to open the floor to discussion, and waiting for the audience, I would like to ask you a question, Jakob, first. TG0 technology enables innovative and meaningful way of product interaction. With the high customization possibility for designers. In terms of accessibility, this is a huge opportunity. Have you ever developed custom interaction to improve accessibility for a product in a design for all or universal design perspective?
It's an awesome question, and personally, I'm very passionate about this use case. Our business model is like we are being commissioned by our partners, by our customers to develop these use cases. So unfortunately, not yet. We haven't been commissioned to do accessibility. We've done some initial case studies and viability studies with some foundations in this area. So one of the issues that service teams working with, let's say, disabled gamers are facing is that the mechanical switches, the mechanical joysticks available on the market now have a preset strength, and various people, various gamers with different disabilities have different force activation needs. So for the service teams, it's really difficult to kind of tune or find the switch or the joystick or the interface that meets the force activation requirements for a given customer. With our technology, everything can be tuned in software. So the sensitivity, the resolution, the response rate, the shape, and because it can be 3D printed, we can customize our device for a given customer. So there's a lot of benefits and kind of applicability for accessibility. We just didn't have the right partnership or the right customer to really take it forward.
Thank you, Jakob, for your answer. Thank you very much. So maybe we have some questions from the audience. Andrea?
Thank you. Sorry. Welcome, Jakob. I bring you some questions from our audience and our research unit. First question. At the end of your presentation, you talk about the sustainability of your technology as it can reduce energy, material consumption, e-wastes as well. You mentioned the possibility of using biopolymers in your product. Have you tasted yet these opportunities or just future plans?
It's mostly kind of blue sky future plans. It is an area of active R&D for us. Currently, to my knowledge, there is no kind of biodegradable polymers that are kind of at the TRL level that is ready for kind of mass consumption. So it's just a future thought. But given how our technology is structured or architected, it's all about the software. The software is the kind of magic sauce. The thresholding, the baselining, the signal processing, it's really all in the software. So as soon as these polymers come online or available, we can quite easily take our IP and adapt it. So why we are here, why we are taking part in this symposium, is that we are very much looking forward to get connected with the academic community. And if you guys have polymers that you want to work with, want to explore applicability of our technology, let's have a conversation.
And you talk about new possible relations with the surfaces, forms, and functions, and you know that among designers, when we use this precise sequence of words, a hard question is coming. And in my opinion, these new opportunities really question the epistemic dimension of the designers of the systems, and how to teach designers to explore these new interactive spaces.
So I'm not sure I'm getting the question. Like, is it a question about our business model? What's the next step, or
how we teach to designers to interact with new possibilities about the relation of forms, surfaces you habilitate?
Okay, so perhaps this is a question for my colleague. So with me, there's Francesca Perona. She's the Chief Innovation Officer. And
hi there, I'm...
Yeah, go ahead.
Hi, nice to meet you all. Yeah, I think it's a great question, actually. I think someone before, when we were talking about performance experiencing, there are different kind of thresholds that people are used to in terms of interactions. So some designers really get the opportunity to work in a different way with technology, and other designers need to be briefed a bit better, I guess. I think there are two elements in here. One is really understanding what are the, let's say, user experience possibilities with our technology. And the other aspect is purely the mechanical design and the application of our technology to those specific shapes that the designers need to work with. So when we work with client, we kind of work on both elements. So we do work together on redefining the user experiencing, streamlining it, and making really interactions more natural. When we look at automotive, for example, there's a lot of focus on being able to create devices that don't need to be operated through seeing a screen. So you just reach for the device and you're able to interact with it. So a lot of the studies that we do are actually kind of blindfolded designing and testing of our interfaces in-house and with clients and with external kind of testers. So a lot of that is actually user studies. So the designer kind of get attuned based on the feedback we get from the customers and from the general public too. Hope that answers the question.
Thank you, Francesca. Now, if we don't have other questions, I thank you, Iago, for your presentation, and I thank also Francesca for your presentation.
Thank you.
Thank you.
Now, I leave the stage to Alberto Calleo.
Hi, everyone. Now let me introduce you Simone Pozzi, CEO of Deep Blue and professor at the University of San Marino. He will give a speech about the EU research agenda for human factor in aviation.
Good morning, everyone. My name is Simone Pozzi, and I will be talking about the European research agenda for the human role in the future of aviation. You may have seen in some newspapers or on the web images like this one. These images are often displayed to show futuristic vision on how aviation could be in 20, 30 years. There is a problem with these images, that these images, they may be true, but they will not happen very soon. The problem is that fact is that the aviation world is a slowly changing domain. It's not a fast-paced domain where there are a lot of innovations. Aviation has been at the forefront of innovation for quite a while, but it's a slowly changing world. Innovation in aviation is a long-term game. For instance, if we take the design and production of the Airbus 380, super big aircraft that is currently flying, we see that there is a timeline here on the left of the slide, and we see that from the first ideas to the actual delivery of the airplane, now the first aircraft, it took more than 15 years. The reason for that is that aviation, whenever there is an idea, we want to make sure that we try it. So there are a lot of prototypes, a lot of incremental innovations, a lot of tests, and there is certification, real flight trials, and all of that takes time, of course. On the other hand, it also means that we, in the community, there is a lot of thinking, a lot of debate, a lot of time to decide what to do. And it is not an exception, the human role. Also for humans, the aviation community got together and started discussing how we see the aviation world for humans in 30 years. This vision is documented in this document, which is called Flight Path 2020, which is the vision of Europe, of the industry, of the policymakers, of the regulators, of society, of the stakeholders in society, of the research community, of the universities, on what is going to happen in aviation, what should happen in aviation in the next 30 years to achieve the goals of staying competitive, of having a safe aviation, of having innovative concepts also deployed in aviation. It includes this document also few ideas, the vision on the human role, on what humans will be doing in aviation in 2050. Let me stress one point. This is a vision document, but in this document, you don't only have the vision. This document is currently being used by the European Commission to decide the fundings of the different projects in aviation. And we're talking about a lot of projects, more than 100 every year, and a considerable amount of money that is given to the industries, to the universities, to the different companies delivering innovation in innovation. So it's a vision document which has very tangible and concrete effects in the community. So there are 4 main research areas on which we agreed in the aviation community as the key research areas to define the human role in aviation in the future. The first area is about automation. The second one is about artificial intelligence. The third one is about monitoring human, and the fourth one is about the required skills and competencies for humans in aviation in the future. So let's start with the first area. The first area is the one of automation. Automation, here on the slide, you have a definition of automation, means introducing a device that does something, does partially or fully, something that humans used to do. So, for instance, in aviation, automation has been introduced a lot, especially to fly the aircraft. This is a simplified timeline, but the key message behind this timeline is that the last big automation was introduced, devices, automation solutions were introduced in the 90s with the fly-by-wire systems with the glass cockpits. From then, we have been not introducing new automated devices, not so many, not with that impact. So our goal for the future is to do more, not only for pilots, but also for all the other roles, like traffic controllers, maintenance people, and so on. In this area, what we want to do, we want to introduce automation solutions that can support humans in both normal and degraded operations. This is the key aspect here, because in aviation, we know that automation is great when everything works well, but in a lot of problems, incidents, and accidents, like in the latest Boeing 737 MAX, we've seen that whenever things start to get worse, because the conditions are not the ones that we anticipated, automation can be very problematic because it makes the system harder to control for humans, harder to understand. So the goal here is to build automation that works well in normal conditions. I would say that we are quite good at doing that, but also when there are degraded operations, there are problems, something that was not anticipated is happening. And of course, we want this automation to work to improve the situational awareness of people, to improve decision making, and so on. The second area is the area of artificial intelligence. Here I've put on the slide two images that are familiar to you, two digital assistants that you have on your mobile phone or at home. The idea in aviation is to start using these capabilities also to assist pilots, air traffic controllers, flight dispatchers. At the present moment, this is not being done. So there is automation, which is quite static. Artificial intelligence with these dynamic devices that keep learning and adapting. This is not happening. This is the goal for aviation, to start introducing these assistants into the operations in order to help out the humans. So in this area, the idea is to find the potential applications of artificial intelligence to enhance human performance. The first step will be to have this kind of smart assistants, followed by AI used to run operations, make operations autonomous. And so this is the next level. The second level, of course, is planned to happen not in the next 10 years, but in the next 20 or 30 years. The third area is called monitoring the human. And the idea here is that if you introduce some more automation, if you introduce artificial intelligence, it is helpful to know the status of the humans in order to better support them. So the idea is to deploy sensors on the humans or in the environment to understand, to measure the stress level, the level of cognitive control, whether we are paying attention to something or whether we are using this other part of the brain where more automatized behaviors take place, the workload, the vigilance, and so on. The idea is to collect information on the status of the humans, feed it back to the machines, to the computers, so that the machines can adapt to the status of the human and help the human out in a way which is more suited to the current, or fitting to the current level of activity of the humans. It's easy to picture, if you are tired, you want a certain type of assistance. If you are well rested, you may want another one. The same if you have a peak of workload, you may want the computers to simplify your job. If you are relaxed, you don't have a lot to do, you may want the computers to help you doing a better job. So this area is called monitoring the human, and it's about improving job design, but also improving operations. So to detect problems of fatigue, workload, vigilance for decision making, and by monitoring the status of the humans. The fourth area is called new skills and competencies, and the key question here is quite simple. If we change a lot of the system, of the current system, by introducing new technologies, by introducing monitoring the humans, do we also need to change the profiles of competencies, of skills of the humans? So the question we want to answer here is if we take these competencies, teamwork and collaboration, communication and reporting, leadership, technical expertise, do they need to stay the same in the next 30 years? So do we need to change the way we train people for these competencies? Do we need to put more emphasis on one of these competencies and forgetting some others, considering the changes, the technological changes that we're going to introduce? We don't have the answer to this one. We just know that it's a relevant question to ask. And if we want to redesign the system, if we want to introduce new technologies, we also need to change. We know that we're changing the work of humans. So we also know that we need to change the competencies and the skills of humans. So this area is called new skills and competencies, and it's about redesigning jobs and redesigning, defining which are the skills needed for these new jobs. It's about changing the way we currently select people. It's about changing the training of these people. It's about being able to hire one person to do one job. Then you introduce technological innovation, you change the job, and you have to retrain that person. So, for instance, to give you one example, if you have selected one pilot to fly an aircraft, but today the same pilot is required to fly a drone, so staying on the ground, you may need different skills. You may need different competencies. So you need to have a dynamic retraining system to take the same person and have the same person do a different job. So thank you for your attention. In this presentation, I've covered the 4 research areas on which the aviation community has agreed, to pay attention and to work to define the human role in the future of aviation from here till 2050. So we have 4 major areas: introducing more automation, in applying artificial intelligence that is currently transforming other sectors in aviation and seeing what we can use artificial intelligence for in aviation, monitoring the status of humans in order to detect loss of consciousness, too much fatigue, too much workload, loss of attention, and aspects like that. And then the 4th area is how do we define the new skills required, the new competencies required from this new world that we are trying to design. So, thank you again. We'll be here to take any questions.
Thank you, Simone. Welcome on our virtual stage, and thank you for your presentation. I'd like to ask you something about as the innovation you talked about, as saying, we usually consider the aviation sector to be always on the edge of innovation, but as you are discussing, those innovations take time to be implemented because of the safety tests and also because of the investment that are involved in the process. And however, technology is moving really fast, especially in the sector you talked about, such as artificial intelligence, also automation, and also enabling technologies suggest interesting application for the aviation sector. And in this regard, do you have consideration about the use of virtual reality in the aviation sector, both for training or also for other staff training, other experiences in the aviation sector?
Thank you for the question. Yes, it is indeed an interesting potential area. It's not that revolutionary for aviation because most of the training that we currently do is based on simulations. We are typically talking about expensive full-scale simulators that really simulate, for instance, an aircraft and the movements of the aircraft. You may have seen pictures of these on the internet. So virtual reality would be a low-cost alternative to these ones. The key issue is the one that was covered, during this morning, is how to fool the body, how to trick the body in thinking that you're really there. And at the present moment, these large-scale simulators, of course, are still better because you can add movements, accelerations, and so on and so forth. But it is a potential area of expansion of application to improve our experience in virtual reality and to make those simulations as good as the other ones, as the current ones.
Yeah, thank you, Simone. I'd ask Andrea if there are questions from the...
Yeah, we got a question from the ocean, the audience, not the ocean, Andrea. Welcome, Simone. About the topic of automation, we see a lot of concepts about the use of drones in different contexts and industries. In your opinion, which are the most promising application and which ones we'll see implemented in the next future?
The drone case is quite an interesting one because it's a nice example of how things usually don't go as planned. The idea for the drones was created by the Americans when they wanted to reconvert, the large, big work drones that they were using in the Middle East. And they thought, okay, we have all those machines, they are powerful, they are big, let's reconvert them to transport goods around the States. That didn't happen. What happened was that today we have small drones for photography, for telemetry, for checking critical infrastructures, for checking for security purposes. So this is happening now. So these are the hot applications right now, these small, lightweight drones doing very short missions in a radius of maximum 1 kilometer. What is the automation side of that? You can pre-compute, pre-plan the flight path, but at the present moment, since we are looking at small drones that you see them, they are really flying around you, we keep having 150 pilot on the ground that keeps an eye on the drone, and in case of any problem, assumes control and brings the drone back safely on the ground. So sometimes drones are equated with high automation machines. Today, the automated part of these small drones is the avionic part, meaning they fly automatically. You don't have to control the engines. This is very much automated, and the flight path. This is automated. But again, the scale is different than the one that we anticipated. We anticipated to have big drones flying all over the world. We ended up with drones taking pictures of real estate or during the wedding.
Yeah, from a person quite scared as me about flying, we talk about security. What do you think would be the most high challenges dealing with cybersecurity? Because when people talk about the projection of technologies on different fields, it's easy to come to the conclusion that the planes will become a sort of IoT devices, and we could do everything from Earth, but it's quite scary from a cybersecurity point of view. What do you think about it?
It is, and it's a weak link. I mean, I'm not sharing any real news to you. It's a weak link because when you design systems like that, you should start from the assumption that it will be hacked sooner or later. So it will happen. The small drones, there are a number of initiatives to embed into those systems what is called geofencing. It's an hard-coded boundaries that the drone cannot extend. So even if you hack it, you cannot bring the drone outside of those boundaries. For bigger planes, the problem is less relevant because, of course, there is no current active uplink of command from ground to the aircraft. When it will happen with the data, the uplink will not really control the aircraft. It will just make modifications to some status, planning or other things. And so you have a lot of counter checks. So it's not something that you do on the fly. Probably we will not activate any real-time control of the aircraft. You will upload a set of instructions and you will have someone on board checking if the instructions make sense or not, and authorize the aircraft to fly the new flight path. So what I'm saying is that depending on the applications, there will be different countermeasures, but I'm not really optimistic, to be honest, because it will happen sooner or later. So it's just a matter of setting up the countermeasures and keep moving those countermeasures, because we know that cybersecurity is always evolving, and so it's hard to be protected once and for all. Safety is much easier. Safety, you do your safety checks, you have the redundancies, you have countermeasures in place, but it's much more static than cybersecurity.
Thank you, Simone. Thank you for joining us. And now let me leave the floor to our next guest.
Thank you very much. And now we are moving to the next guest for this morning session. So I'm very, very glad to have together with us today, let's say, a colleague and a technological project which represent a kind of benchmark in the development of the, let's say, gesture, tactile, and haptic experience. I mentioned Ultraleap. Ultraleap is a company based in UK, which is focused on promoting such kind of technologies. But I would prefer to not anticipate nothing about that and to leave the floor to our colleague, Orestis Georgiou, which is director of research at Ultraleap. And the topic of his speech is connecting through touch, creating tactile experience in mid-air. So the floor is to Orestes' speech.
Hello and welcome to my talk entitled Connecting Through Touch and Creating Tactile Experiences in Mid-Air. My name is Orestes Georgiou and I am Director of Research at Ultraleap, a company that is on a mission to make the world a little bit more magical. Right, so we believe that we have a really big problem in immersive reality. While the visuals and the audio that we see are incredibly compelling, we're completely missing feedback for our vital sense, a sense of touch. And we get so much more information about the world around us every day through the sense of touch. In fact, we are fundamentally dependent upon it for carrying out simple interactions that you and I take for granted, such as picking something up and moving it around, or taking something out of our pocket. So we believe that haptic feedback can be so much more than just rumble, like you get on a games console or on your cell phone when it vibrates to let you know that you got a text. Touch is both discriminative and it's functional, but it's also social and affective. It's a key aspect of how we connect and how we experience the physical and digital world. And more than that, we've got to move away from these handheld controllers if we are ever going to have a feedback mechanism for touch that is widely adopted for virtual and augmented reality. It's gotta be, it has to be low friction. You can't have to wear extra devices on your hands. You can't have attachments that the users have to go and put on themselves in order to go and have an experience. So what we've done is we've developed a haptic technology that you can simply walk up and use. It uses sound waves to project tactile sensations and vibrations through the air and directly onto your hands and fingertips, so that not only can you see and hear holograms, but you can now also reach out and touch them and feel them. Specifically, the technology uses ultrasound, so it's sound that is too high frequency for you to hear, coming out of a speaker like the one that you can see on the left here. The speaker is made up of many smaller speakers, and what we do is we precisely control the timing between the speakers so that all the sound waves arrive at the same point at the same time. And then we move that point around to create precise vibrations on your skin, like the shape of a square or the feeling of a tennis ball. In fact, we have created a sort of tactile basis of sensations and patterns, like an alphabet that we can construct words with and put into sentences conveying some kind of tactile meaning that feels similar to whatever you might be seeing, for example, on a screen, like we did in our collaboration with Lego called Rebuild the World, where you could pick and place virtual Lego bricks, or we can enable you to not have to look at the car dashboard and just feel the infotainment system's buttons come to you, as we did in our collaboration with Peugeot and their luxury concept car, the DS Aero Sport Lounge. And we can even enable blind and visually impaired people to experience tactile movies, as we've done in our collaboration with the Aquarium of the Pacific. Details about these use cases are available now on the Ultraleap website, which I encourage you to go and have a look. Because also on our website, we have a knowledge base and links to our developer site, where we work really hard to create code examples and work through guidelines to help designers and developers to build their own applications. So as a company, we've also embraced the concept of open innovation. And we publish open source code on GitHub and collaborate with over 80 universities around the world through our academic program. In our journey, we've been very lucky to have experimented with all sorts of fun and interesting human-computer applications. And I'd like to mention a few here. We worked on enhanced shopping experiences. For example, people can simply reach out and touch and explore and manipulate haptic holograms of products that they are interested in. In virtual reality, gamers can feel things that don't really exist in the world, like casting magical spells and feeling lightning or fireballs flying out of their hands. And in digital signage, cinema goers can touch and engage with interactive tactile posters, all of this without having to worry about touching potentially contaminated surfaces. And finally, in augmented reality, workspaces can become enhanced through tactile experiences. So for example, you can feel a holographic heart organ that is beating, and you can actually reach out, touch it, and feel its rhythm. So let me talk a little bit about the trajectory of the company that I work for. Ultraleap, which used to be called Ultra Haptics, was a spin-off company from the University of Bristol in the UK. It spun out in 2014 out of a PhD program, actually, and has since grown to over 150 people, collaborative teams that are split across our two offices, one in the UK and one in California. And in 2019, Ultra Haptics joined forces with the US company Leap Motion, and we renamed the company to Ultraleap. Leap Motion is famous for its leading optical hand tracking technology. And this year, we're really excited to be launching a new and improved camera module and software engine, enabling even faster and more accurate tracking of hand gestures. Together, our ultrasonic media haptic technology and our infrared hand tracking technology actually work really well together, hand in hand, to close the gap in spatial computing and enable all sorts of new human-machine interfaces. And we've been really lucky to have been trusted by a number of big brands with whom we've worked together to develop amazing new experiences and products like the Peugeot concept car I mentioned earlier. But before I close my presentation, I'd also like to emphasize our commitment to excellence and innovation, something that we are constantly engaged in. And one way we get to do that is through R&D projects. And I'd like to mention 4 Horizon 2020 projects in particular that we are part of. And these have been funded by the European Innovation Council. So first up is the Levitate project, where we teamed up with acoustics departments and HCI groups to develop a levitating display composed of small and light particles, which we can control through ultrasonic forces. So this is basically a real-life physical hologram. Our second and third projects are called H-Reality and E-Textures, where we have teamed up with VR and haptic experts to create touch dimensions of textures like media roughness. And finally, in our project Touchless AI, we're bringing together for the first time neuroscience, artificial intelligence, and ethics to create novel touch technologies that can go beyond functional haptics and enable high-level user experiences. And on that note, I'd like to thank you very much for your time and your attention, and I would be very happy to take any questions.
Orestes, thank you very much. Are you there? Hi, hello, nice to see you.
Hi, nice to see you too.
Great to see you, and congratulations for your presentation. It was amazing. Thank you very much. And thank you for mentioning also your role and activities in EU projects, and in general, the role of the EU projects in promoting research. So thank you for that as well. Just a couple of questions from my side, one in particular, and then I leave to Andrea one more question. So there was a lot of things interesting in your presentation. One of them was that because of the, let's say, your technologies, you are expecting to reduce, for instance, a glance percentage in, let's say, secondary tasking driving at about 25%. And that's very interesting for safe and in general for design HMI for automotive. I'm just wondering if you are elaborating or you have done any design recommendation for designers that have to use your technologies when they have to create, you know, meet their tech-haptic interaction experience.
Yeah, thanks a lot. That's a great question. We have published and run studies to give these kind of design guidelines to designers, but also haptic designers and system designers. So depending on the application that we have in mind, like the one you mentioned about automotive, we have a list of kind of top 10 things that we have learned through our study in developing this prototype with PSA. And these kind of includes, you know, things like how to test, think about ergonomics, add multimodal features to various interactions. And these are there to improve the user experience, increase the sense of control, the sense of agency given to the operator in this case, but also to make things more robust and reliable, because depending exactly on the use case that you have to prioritize what is more important. So for example, if it's something that is really a safety critical application, then we really need to focus on the robustness, reliability, task completion time, things like this. And there are guidelines that you can find both in various academic papers that we have published specifically for this automotive one, but also on our knowledge base on our website. So we've built separate and interlinked pages describing how to create these experiences, what to think about, and enable customization at the same time, because the design space is just massive. So we want to share our learnings, and we encourage others to also share their learnings so we can learn from them.
Thank you, Orestes. A great reply to my question. So Andrea, for you and for the public.
Two questions from our research unit and from the audience. We talk about perspectives and impacts. First part of the question, in your opinion, how does the pandemic and future scenario will change the way we interact with devices? So how actuality changes the relation with this technology? And the other part of the question is more projecting the future. Which aspects of society will be most impacted by touchless devices?
Wow, great question. So in the first case, the first question, I think the obvious answer there is that people are a lot more aware of what they touch and what they interact with, especially in public spaces. I think we've internally run a study with a large number of participants actually to see what is the perception during the pandemic and more recently, how people feel about interacting with things like ATM machines or self-checkout, self-check-in, ticket vending kiosks, and so on. And a large amount, so over 50% of people are very aware and very concerned about what they would touch and interact with, because you can't really, put your gel to clean your hands every time you touch something at every location you are out. This is not a functional relationship with user interfaces. So this is an area that we've identified almost immediately, and we've seen a huge change in also the companies that come and talk to us and say, hey, we like your technology, we need your technology, we'd like to develop so and so solutions. And I think we've recently launched a solution which we call Touch Free, and it's kind of a plug and play where you install a camera module, update some software, and your touch screen interface becomes touch free. And so people don't need to touch that screen when they're interacting. And along with this, there's a number, just to return to your previous question, there's a guidelines about how to install this, how to set up, how to maybe change a little bit the UI so that it becomes more effective and nicer to interact with. To come back to your second question, if I remember, kind of a broader view of how touchless interfaces will be impacted on the longer term. Just like now we're having these virtual conferences and we're in Zoom meetings all day. So that's something that has taken away in this virtual transition, the sense of touch and also the sense of the body and the embodiment when we have these kind of conversations and we connect with people online. So that is a very interesting question, and there's all sorts of aspects that deserve a whole new attention from a research point of view. How do we communicate touch remotely? How do we not lose embodiment, ownership, and presence remotely or in digital immersive scenarios? But also more kind of fundamental questions like in terms of gender, ethics, which we need to think about again. If we are to introduce touch in remote communications, we need to think about these things, and we're starting to think about this at least.
For mentioning this responsible research approach that's quite central in our life today. Another last two curiosities from our audience. Lorenzo Monti is asking, thanks for presentation. I would like to ask you if it's possible to play an instrument with the levitation, like theremin, for example. And then Roberto Berganti is asking if the use of ultrasonic does not interfere with other frequencies, such as the hearing of animals and so on.
That's great questions. I have very short answers to give in both cases. So yes, you can definitely build musical applications like theremin or any other kind of interesting touchless, touch-free musical instruments that you can interact in midair, recreate those instruments through gesture input, and feedback the touching those instruments, but also the rhythm associated with that music, maybe, so you can keep the beat or something like this. And there's a ton of nice applications developed all the way from student projects to more kind of advanced and even commercialized cases in some cases of musical interfaces. The second question was about any interference with animals. So I have a very short answer, and the answer is there is. Okay, so I have a more interesting answer. So we use 40 kilohertz ultrasonic speakers, and they're essentially the same as those used in most parking sensors. And while there is overlap at 40 kilohertz with the hearing spectrum of some animals, like bats, some cats, and some dogs, we haven't seen. There is no evidence that they are annoyed by the ultrasonic output. So not in our devices, not from parking sensors. So there is an overlap, but there is no interference.
Thank you very much, Orestes. Thank you, Andrea, and the colleague from the public for these great questions. So congratulations again. Thanks for being with us. And I will ask you to keep in contact and follow the rest of the meeting. Thank you very much, Orestes. Have a great day.
Thank you.
Okay, I guess that we have another host. Colleague is coming.
Yes, thank you.
The floor is yours.
Thank you. Thank you. And now please let me introduce you Scott Novick. He's co-founder and chief revenue officer at Neosensory. We'll talk about Neosensory Buzz, a journey in designing effective sensory augmentation system.
Hi, everyone. I'm Scott Novick, the co-founder and chief technology officer at Neosensory. And I'm excited to be speaking with you all today about sensory augmentation using our company's product Buzz as a driving example. So a quick bit of background, if you haven't heard of Neosensory, we develop wearable platforms for giving people new senses. A good example of that is our first product, which came out last year in February, called Buzz. Buzz is a sensory augmentation wristband that out of the box maps sound to touch. So it takes in sound from the environment in real time through its onboard microphone and provides you with a real-time low latency representation of that sound using vibration around your wrist on 4 vibrational actuators. So for example, if there's an ambulance going by with a siren, you'll kind of feel the frequency sweep of vibration around your wrist. Likewise, if someone were to knock on your door, you'd feel that kind of knock, knock, knock pattern on your wrist as well. But this is a platform, even though it runs this algorithm out of the box, we have an open API and open source SDKs that enable developers to plug in whatever information streams they want into this band. So a little bit of history. This project started out as my PhD work with my former PhD advisor, now co-founder, Dr. David Eagleman. We originally developed this as a vest that had 32 vibrational actuators all over it. And the goal was to provide enough information of sound from the environment such that someone who is completely deaf could come to understand speech. So we created that and we got great preliminary data. David gave a talk at TED. That's a QR code to his TED talk about this. And then we launched Neosensory, and after a number of years and a number of iterations and user research, we ended up with a wristband. So I'll explain a little bit how we got to that in a bit. But before that, I want to explain what sensory augmentation is. So sensory augmentation is the idea that there's some information out there, whether it's sound, stock market data, weather data, sensor data from drones. And the idea is we want to train up a new sense of that. We want to perceive that information kind of natively in the way we think of sound, vision, or touch. And we can do this non-invasively by encoding this information to some target set of sensory receptors on our body, as long as we do it in a smart enough way such that we try and guarantee that as much of the information that we care about makes it to the brain. So it's the job of the sensory augmentation device to bridge that gap. So this device needs to take information from the environment and find an appropriate mathematical representation of that and an appropriate encoding for our set of target sensory receptors on our body that tries to guarantee that as much of this information makes it to the brain as possible. So unfortunately, I don't have enough time to get into this in any amount of detail in this talk, but here's a link to my PhD thesis, which goes into this in a fair amount of detail and provides kind of like some great underlying examples of the math involved and how you think about creating these algorithms. But we can go a little bit deeper in detail first. So taking Buzz as an example, Buzz has 4 what are called linear resonant actuators. So these are little vibrational units. And they are specifically designed to target a type of receptor, sensory receptor in our body called our Pacinian corpuscle. So these are mechano or touch receptors underneath our skin. And here's a great, this QR code links to a great talk about how those work. And so our Pacinians, they fire action potentials to the brain in proportion to the vibration amplitude being applied to that receptor. In this case, they pick up on vibrations between 50 to 300 hertz and amplitudes on the order of 0 and 0.1 centimeters. And they can detect changes in vibration on the order of like 5 to 10 milliseconds. And this is the sweet spot for what LRAs and a lot of other off-the-shelf consumer haptic vibration technology targets. So the LRAs that we use in Buzz, they vibrate at a fixed frequency of 175 hertz, but we encode our information using vibrational amplitude over 256 discrete or 8 bits of levels around the same amplitude range. And the LRAs can change intensity at approximately 16 milliseconds or so. So it's really the case that the Buzz is, the hardware in the Buzz is kind of more the bottleneck than the receptors are themselves in this case. So given that, because Buzz has 4 vibrational actuators and we understand how many different levels of amplitude we can encode and the rate at which we can encode that information. From a digital signal processing perspective, we could say Buzz encodes an 8-bit quantized 4-dimensional signal with a 62.5 sample rate. If that sounds like a bunch of junk that I just spat out to you, no worries. Again, oh, here's a QR code to one of my former thesis members' books on digital signal processing. And also, again, check out the thesis. But this basically gives us a really powerful framework, a mathematical framework for how we can think about, given some input signal, which we've mathematically modeled, it tells us how we need to shape the signal to fit this kind of output constraint to get this information to our brain. And the assumption is that if we're encoding this information within the constraints of our receptors in our body, that should be enough for the brain to train up on that information, so long as we're not throwing too much of it away when we compress it. So with that being said, that's a quick tour de force of sensory augmentation. I just wanted to go over some quick learnings that came to me thinking about how we got from our vest to this wristband where we are today. So the first lesson, and this doesn't apply to just sensory augmentation, and it's probably pretty common sense to all of you, but it's the importance of doing user research. So when we started Neosensory, we were a bunch of academics and we were really focused on running scientific studies. So we put a lot of time and effort into developing our vest prototypes. And to be fair, we're still working on our vests, but at first we didn't do much user research. And we went out the door with these beautiful, awesome vests and ran these scientific studies, got some good data back, but then we also started getting feedback from these users who are deaf that they actually didn't really care about learning speech, but they did mention that they were enjoying the experience of getting all sorts of other useful environmental information happening around them, whether it was stuff that was more emotional, like being able to feel the sound of their children laughing, or more useful, like knowing that the water is still running off their sink. And because of that, that told us, okay, if people don't care about speech, we don't need 32 vibrational actuators on the body. We can get away with a lot less, something like 4. So that really drove home to us. And that was a great lesson on the importance of doing user research early on when developing a new product. The second lesson, and this is more sensory augmentation specific to a degree, is it's really important to design for compliance or getting users to wear these devices kind of all day, every day, from when they wake up to when they go to sleep, even maybe when they're asleep, because when you strap these devices on, there may be information that is immediately obvious and useful that you're getting, but your brain really does need to train up to understand this information in a more perceptual sense or to a higher degree. So here's a quick shot of some results from a recent paper from our scientist, Mike Parada. Also, that's a QR code link to that, but this just shows how people perform at identifying different sounds through the buzz who are deaf over the course of several weeks. And as you can see, it takes weeks and actually months for the brain to rewire itself to a large degree to train up on this information. And so because of that, when designing these devices, it's really important that they're designed in a way that people are willing to wear them pretty much all the time. And so in that case, that strongly guided us towards a more kind of user-friendly form factor that people were comfortable with, like a wristband rather than like a giant kind of clunky, bulky vest. At least for the use case of people wanting to just train up on a general sense of environmental sounds happening around them. And so those are the two big major sensory augmentation learnings that we had in our product design and development. But just to close this out, beyond that, I just want to reiterate again that Buzz and the technology we develop is meant to be a platform at the end of the day for people to build all sorts of cool sensory expanding applications on top of. So we have a burgeoning developer community. This is just a small sample of what's going on, but people have been creating all sorts of really cool applications, like providing sensory feedback for those with prosthetics, more out there ideas like sensing electromagnetic fields or performing echolocation so you can navigate without vision. One of my favorite recent projects that I've seen out of our community, and they're actually spinning this off into a startup, is called Valence, and they're running a sentiment analysis on speech audio to act as an emotion or social aid for people who are neurodiverse. But the sky's really the limit. And so for those of you out there who are just learning about sensory augmentation for the first time through this talk, totally encourage you to check out our developer site, neosensory.com/developers. Would love to see you playing around with our tech, and we have a Slack channel. We have a Slack workspace you can also join. So, and that's about it. So it was great speaking with you all today, and I'm looking forward to your questions. Thanks again.
Thank you, Scott. And thank you for joining us.
Yeah, thank you for having me. Excited to be here at 6 in the morning. No, it's awesome. Really cool. Love seeing all the other talks that have been on here.
Thank you. Thank you also for the early leave. So
no problem.
And it's really interesting to see the design transition you actually did from a full-size vest to a wristband, which actually led to a more immersive and a more also effective way for users to feel this the augmentation of the senses. And to this regard, and also to the community of contribution about this project, sensory augmentation seems to have all the potential to find application also in field such as immersive experiences and exhibition, but also working environments. And what's your view on this topic, on these possible applications?
Yeah, that's actually one of the big things that we're really excited to be exploring and see other people also exploring. And that's what makes this technology so challenging, because there's so many things you can do with this simple device. But yeah, in terms of so like one of the big things, and this isn't immediately obvious to people because of the, out of the box, we're running kind of the sound to touch sensory substitution, which is it's already sort of like a native sense that we're used to. We're already used to sound. But one of the big enabling things for this technology is providing information streams to users that aren't already kind of pre-existing senses that we're used to. And that's something I'm really excited to see a lot more applications for. So being able to feel the state like if you think of just any arbitrary information stream like that's coming off of sensors from a factory or a quadcopter or something like that, you can jack that data into the body and feel what it's like to be a factory or feel what it's like to be a drone, and hopefully develop kind of useful perceptions around that. And that's something that I'm really looking forward to see more of with our technology, or with sensory augmentation in general.
Thank you, Scott. Maybe we have some question from our public.
Yeah, got a question coming from our research unit. Thank you again, Scott, for being here with us. In order to further specialize the quality of the communication to the end user, what do you think are the most promising technologies to use in combination with tactile simulations?
Oh, in combination with tactile stimulation. That's a really interesting one. Because I mean, I guess it's definitely, our senses definitely fuse information, our senses definitely fuse information cross modality. I actually hadn't given much thought to providing kind of a fused augmentation. So if I'm understanding the question correctly, the idea is, in addition to tactile stimulation, what can be achieved by, say, using another modality such as sound, for example. That's a really cool concept. I honestly hadn't thought of that within kind of the operating framework for what we're currently doing, but you could definitely, I mean, it's certainly a possibility. Sorry for such a generic answer, but does that
about that? I just bought a domain, complementary technologies to use with Scott Novich's tech stack. Let's talk about it. Thank you again. Ask to Professor Zannoni and Berto Mantovani to join the stage to end up this conversation. Thank you.
So, ladies and gentlemen, public, we are at the end of the morning session. So we are going to have also an afternoon session with some workshop and nice things again. So it's not finished, but let us take some, some times for saying a few words. First of all, I want to make an announcement, which is very important, because let's say in the line defined by this morning session and whatever we will be discussing in the afternoon, we are working with collecting and creating, let's say, part of the issue of the next DIID scientific journal, which is number 74, expected in September 2021, in which, of course, according to the peer review process, there will be some intervention which describe what happened this morning and what will happen in the afternoon. So stay online on this topic, because there will be a lot of materials coming from today's meeting and what we have discussed also in this important scientific journal, Disegno Industriale Industrial Design, DIID. Second, just another technical announcement, which is very, very important. So we are going to meet again this afternoon at 15:15. So 15 past 15 for the different Zoom sessions. So all the Zoom session will start a quarter past 3 o'clock in the afternoon. Oh, sorry, a quarter past 3 in the afternoon. And so if you are interested in one of these sessions, join directly the Zoom link that you will find in the program. So that's for the, let's say, technical and perspectives. I leave the floor to Michele for the final conclusions.
I come all the teams that work to the symposium for the last image of the morning. I have to give a big thanks to all this extraordinary group of persons that work very hard to arrive to this achievement. Marco Pezzi is, where are you? Thank you. And Giorgio Dall'Osso, Luca Barbieri, Alberto Calleo, Andrea Cattabriga, Arianna Frantesini, Lucrezia Rivecchio, Ludovica Rosato, Eleonora Malacchia, Gioacchino Mastroli e Kay Scampa. Thank you.
Thank you very much.
Thank you to everybody.
Let me add one thing. When it happens when a concert and the band is working, is arriving in the end, there is a special thanks to the major vocal, so Professor Michele Zannoni, which is
thank you to everyone
behind everything. So thank you very much.
Thank you.